So that,
Can you check with them?
Okay.
They're able to hear you.
are you able to hear me clearly?
Yes.
Yes.
Fine, so we can get started. Let's get started. So I know some of you asked on Thursday, and a couple of you dropped out. We won't need a laptop tomorrow either. But what we're gonna do it tomorrow, and that's why it's an important. Hang on, let me admit. Marshall, were you able to?
Yes, I was able to.
Okay. So tomorrow we're gonna start doing the hands-on work. So make sure you are back on time on tomorrow. We'll get started as today. If you, I would always recommend is get in if you can, if you're like it's working online. If it's possible, come in the classroom because it's the interaction and the discussion is going to be very helpful. So it's not that you can't do it online, you can, but it won't be as effective as you're doing it in person. So bring your notepad, pen, pencil, whatever you like it. We're going to start doing it hands-on exercises starting tomorrow. Okay. So last week we kind of stopped at the software requirement. Right. As a homework, you had an opportunity to review the requirements document. And as you went through it, it just essentially went through a whole bunch of sections, starting from getting the background of why the system is trying to be built, what problem it's trying to solve it, to specific detailed characteristics of what are the functional and non-functional requirements, what is expected operating environment for that particular system. Okay. Then you also reviewed the system design document, which started talking around what the system architecture is going to look like it, what is the data elements going to look like it, what kind of interfaces it's going to have it, right? And then you also looked at it, the page flow diagram. So that's the whole aspect in the analysis and design phase that the development team does. You look in it from a quality assurance person to do that. Now, there is another piece of aspects that the quality assurance person does it in the initial analysis phase. Once you get the document, right, you have to start laying it out, a proposed vision or plan of how you're going to actually test that system. Remember, one of the things I asked all of you to think about 3CNT, right? But you also need to think about it as you go through 3CNT, how are you going to actually execute it and validate whenever the system is built, it is built according to the requirements document that has been laid out. So you start working on something known as a test plan document. Okay, so let's start talking about it. But before that, let's start talking, understanding it is what is the object? Why do you even bother doing the testing? What is the main reason behind trying to do those testing and a quality assurance, right? So often you think about it like it's you're doing a testing with the goal of finding an error, right? Whenever it says, hey, are you testing it? Your first thing will look like it. Hey, is there a problem with it? That's what I'm doing it, right? I want you to think it flip side. We're using testing. You're proving it that it works as expected, and then there is no error, right? So a lot of times your successful test, right, will you assume it that, hey, it's going to tell me that everything works, right? But the whole purpose you're writing the test, to think about it, is after the fact, to figure it out what is wrong with the system, right? So it's kind of like it's depending on what viewpoint you look at it, right? A successful test, some people will recognize that, hey, I validated everything works as expected. Some people will think about successful test is the one that enabled me to find the error, which was present in the system that it was not detected before, right? So be mindful, like it's as and people ask it, there's two different viewpoints on that, right? So the whole goal when you do a testing is you want to find as many errors as possible, right? Ideally, if you've done a proper quality assurance work, your testing turns out as a validation that the system is built properly. Okay, so that's the whole purpose of it. It's become so validated. Is it working as expected in there, right? One of the other aspects that you check it for the system is it fit for purpose? By fit for purpose means that it's not only works in terms of it's performing the functionality, but is it also usable or not? Right. So for example, if you build a system and says it meets all the requirements. However, every time you're trying to like it's do something in the system, it takes 5 minutes to get the response back. Is it fit for purpose? Most likely not, right? Nobody will want to use it. Does it work? Yeah, it meets the requirements, but it doesn't meet some of the operational requirements. So the intention is when you do the testing, it is fit for purpose from both functional and non-functional operating point of view. Okay. Now, you typically start doing a testing with not everything in one big giant thing, right? You're going to take one small piece of requirements at a time and then start testing it. Remember what I say, it's every requirement, you're going to look at 3C and T, right? So potentially everything that you build it's going to be building in a small building block that collectively comes together to test the whole functionality of the systems, right? So that small piece that you build it's typically known as a test case. Okay. And the test case has some characteristics as you write it, right? You want to make it sure, the test case has the highest probability of finding the error, because that's the goal, right? You're trying to find it where the system is going to break it, right? So that is what you want to do it. If it's trying to find the same error that you already know of it, is it worthwhile spending your time? Probably not, right? Because you already know it. So one of the characteristics you need to think about it is it's not redundant. That means it's doing the same thing that something else is also doing it. Okay. And as we go through it, we'll talk about with the example, what is best of breed means, right? As well as what it means to be a simple or a too complex. Okay. You don't want something that, hey, it's only one step and then it's done. You don't want anything which is kind of 50 steps and trying to test 5 different things, right? That's not ideal either. Okay. So we'll look through it. Okay. Bugs are nothing but the defects in the system. So as you find it, anything that does not comply as per the requirements or any deviation from an expected behavior that you identify, it's essentially a bug. Okay. The whole goal as a software tester is to understand the application well, right? So think about it. What did the first thing we ask it? Read the entire requirements document. Okay. In my view, there's only 2 people in the entire software delivery team who knows the system very good from end to end. One is the architect, the person who designed that and put everything together. And the second one is the tester or a quality assurance person who essentially puts things in place, going hands-on and says where things is going to break it. Okay, so that's a critical role as you go through it as a quality assurance person. He has a very good understanding of that. That's why when you go look at building a test, you're not only thinking around only from that testability, right? One of the first things we do it is 3C, right? It's correct. That means, does it really belong here? It's not just blindly following and says, does this work or not? Does it really belong here? Right? That's the contextual part that you're trying to bring it out together. Okay. Again, they're going to build the test cases. They're going to help you find the bugs. So now what you're seeing here is known as a software testing cycle. Okay. So if you recall it, like we did the software development lifecycle, right? Start with the planning. What was the next phase? analysis, then design, implementation. Fifth one is testing, then,
Deployment and maintenance.
okay. Deployment is also categorized as something else. Acceptance, right? So keep that picture in mind and then start talking about, if I'm a tester or a quality assurance person, where does actually my work start? The work starts understanding the requirement, right? So first thing as you did is you read the requirements. Okay? As you read the requirements, what did you do? What are the things I told you? Apply 3C and T, right? What does T means? Testable. Well, and what is the question you ask in testable? Does it meet the requirements or not? Can I test it? Can I write something that tests it and tells me answer yes or no? Simple. Right? What is that? That is nothing but an acceptance criteria. How would I accept a system that fulfills that requirement? How do I know that it meets it? So that testing condition that you're writing, it's nothing but an acceptance criteria. Okay, so the first thing is you understand its requirement. You start laying it out. What exactly is the acceptance criteria is going to do to see if this thing is fulfilled or not in a given system? Okay, then once you understand that, it says, okay, now that I know it, how am I going to go about testing it? How many test cases I need to write it? Right. For a given requirement, if there are multiple acceptance criteria, do I need to break it down into multiple test cases? Or can I write a big test case that covers more than one requirement? Right, that kind of strategy and plan. Right, so for example, right, when you talk about one of the requirements is, as a user or a super user, I should be able to create different types of user, right? Dealer user, lender user, right? Outflow and rep user. It's a one requirement, but there's a lot behind it, right? That means I need to write an acceptance criteria that, hey, am I able to create a dealer user successfully? Can I create outflow and rep user successfully, right? So there's going to be a one-to-many relationship. And that for each one of them, you're going to say, hey, you know what? I need to write test cases. We talked about the mandatory and optional field for each one of the user creation, right? That means I could potentially write multiple test cases to see what happens if they don't specify mandatory. What happens if they put all optional field in it? What happens if they don't put an optional? Does it still able to create it? Right. So there are different things that you need to think about in scenario. That's what you do it in strategy and planning and design. And it's not only different scenario, right? You need to start writing a detailed step-by-step instruction of how you're going to go do about it. Right. And we'll start dipping into that tomorrow. Okay. Once you do that design, and then you have like script that, hey, I'm going to do this. Right? So let me give you an example, right? If you're making a dinner, right? So you'll start laying it out the requirements, right? That, hey, what do I need to make it? Right? Let's say if I'm making an Italian, right? You'd say, hey, maybe I want to start with salad, want to do it some sort of pasta, right? And do some sort of a dish, right? That's my requirement. Then you start putting in acceptance criteria. Well, what all needs to be in the salad? What is the quantity needs to be it? Type of thing, right? Well, how much pasta, what it is. Then you think about it, if I need to cook pasta, what all things I need to do it, right? I need to probably get all the ingredient listed out. I need to get probably the instructions for the cooking and everything. Right? My requirement, acceptance criteria, figuring out how I'm going to do that. Once you have all that thing, you're going to execute, right? You're going to start making the meal. Right? The developer gives you a code. You have a plan to test it. You start executing against it to figure it out. Is there a bug? Is it working as expected? It is not working as expected, right? All of that. As you work on that, you're going to find certain things that is not working as expected. So you just essentially create a bug or a defect and says, hey, this thing was supposed to do this, it's not doing that. Here is the condition that I ran through it. Here is what I observed it. Here's what I'm expected it, right? So developer goes, looks into it. They fix it, goes back. You need to retest it, right? Did they fix it right? Did them fix it right? Right? cooking the meal, I cook the meal, I need a tester. Is this spices properly? Is the salt in it right? Is the pepper and all of the spiciness is right? If not, you add, enhance it, bring it back to the test. Then to look at review and audit, right? I ran through all of the test cases, done through all of the defect, retested that everything is working. Let me look through it. Did I have all the functions tested? Is all of function passed? Is it within the parameters that I expected, right? The fit for purpose? Is everything ready? If so, I'll say it's okay. This software is good. Let's just baseline it and we are ready to move on. Right. So that's the testing life cycle. It closely tracks it from the requirement phase onwards. Right. So if you see it, there is no planning phase in here. Because remember what we said, planning is about, do I need to build the software or not? Right. Once I make that decision, then it goes through it. So this thing is known as a software testing life cycle. Any questions so far? Online?
No.
Let's go ahead. There's another model you're going to encounter when people talk about the software testing life cycle. And that's something known as a V model. Okay. So think about it as the software is getting built, right? What typically how the developers will think about it. Okay, so they understand what is the requirements, right? They take that requirement, and we saw it in the detailed design document. They started breaking it down into the functional components, right? So the next thing they do it is, I have a requirements, I'm going to bring it into the functional specifications. Now, once you do that functional specification, you need to get in further detail down from a developer point of view, right? So one of the components they put is security, right? So if you remember, like it's in the detailed design document, well, it's good. I need to build a security component. Well, what it means then? What kind of security? How I'm going to break it down? It's going to be different for different user, or I'm going to build a single framework that every login goes through it, right? Another example is managing the dealer, right? It's great. Manage dealer. There's a whole bunch of part of it is creating a dealer, right? Updating a dealer or viewing a dealer, right? Those are three different functionalities that they do it. Also, there's something called, I'm going to add notes for the dealer. That's an additional functionality. I'm going to break that functional specification into sets. Okay, here is how I'm going to create it. There is a second technical module, which is going to go ahead and update it. There's a third one that allows me to attach notes to a dealer, right? So you break it down, those things. And then you take it, okay, now I'm going to create it. Well, how am I going to create it? Right? What screen is going to be displayed? What are the fields going to be mandatory? How I'm going to check it? Whether it's a number, text, whatever the right proper field is, right? All those things are a detailed program specifications. So a developer goes through that, break it down as they go through it. Okay, then they write the code. So that's the developer. So if you track it from a quality assurance person point of view, right? At each stage, right, there is a different level of detail is visible to you, right? So what you do, when you have a user requirements, okay, all you have is you can do an acceptance criteria, right? 3C and T, the testable aspect. So you will start writing something known as user acceptance testing. From a user's point of view, without knowing anything in the system, how I'm going to write a test that validates that system requirement. That was a functionality that was defined. Okay. As they get breaking it down into this functional specification, now I don't have one single systems. I know that system is broken into different components. Going back to the system architecture definition, right? The Lego example, everyone is going to be small pieces. You're going to build it together, right? So this one is talking about can I connect them together? Can I piece them? I'm not worried about how each individual Lego piece looks like it, but can I connect each of the pieces together and understand what is the relationship between them? I have different functions. I'm gonna build a system test that essentially allows me to test across multiple components to see, are they working together as expected? Okay. Now that I have the detail of, hey, there is a security, there is a managed dealer, there is that, can I stitch together a test that allows me to test across multiple to see is the connection working as expected? I don't have to know the detail of how each of the component is built, but can I just put the two pieces of Lego together and just, do they connect it? Right? Clear what system test is we will do it? Right? I have that detail, so as a quality assurance person, I can start writing those tests. Then the next one comes as a technical specification. Right? So what we talked about in technical specification, managing the creating the user or the dealer, updating the dealer, attaching the notes, right? So now I have a little bit more specific. It is, hey, this particular module is creating a dealer. Once they create it, can I attach a note to it, right? So there's a linking test that it tries to perform it as it goes through it. As I have more detail, I can write it a little bit more specific tests to do them. Remember, all of this thing is additive to it, right? This is high level, I'm drilling it down, so I'm adding more and more tests as I go through it. Then the next one comes in is, I know exactly how to create a dealer. Can I write a test case to test it? Is it accepting all the required fields? Is it making it sure when the dealer ID is created, it's enumerated? Right. Franchise number created for the dealer. Does it follow that rule of state, county, and the unique zip code? Right. So all of those things will be done by unit test. Then you write the code. Till this point, all you're doing it is going back into the previous one. You're performing it, planning and designing. Like you're just writing it. There's no software for you to test it yet. All you're doing it is based on your understanding, you're writing step-by-step instructions of what to do it, right? For example, the recipe, right? I'm making a pasta. I'm writing a recipe. Hey, I'm going to do this, then I'm going to do this, I'm going to do this. Okay. But I haven't bought anything, right? Then I go bring the pasta, bring the vegetables, bring the sauce, bring all the spices together. I have all those things ready. Now I'm going to start executing it. As I execute it, I'm going to validate, is my recipe, I'm going to follow that. And is it working as expected? Right. So once you write the code, think of this arm as a planning arm. This arm is execution arm. Okay. So I'm going to start testing the individual pieces. Now I know that creating a dealer works fine. Then I'm going to say it's okay. Now, as I build each component, I'm going to link them together. As each functions comes together, I know I have system tests. I can start testing them. And then once the whole system is built, I can start doing an acceptance test. Okay. So this is another way to look at the life cycle, is from how the developers are progressing it to do that. This one is more the project type level life cycle. Right. So when you talk about the planning, execution, and design, if I have to drill it down, there are 4 levels that as I go through it. Okay. Any questions so far? Do you understand the cycle, how things comes together? Right. That's what we're talking about. You don't start once the code is built to do the testing. You start way up in the requirements phase. As it goes through it, you're building your, what I call it, is assets that essentially enables you at the execution time to be more effective. So now that you know how all those things works together in the life cycle, let's take a step back and say, in the requirement phase, essentially, your project manager is going to do it, like it's just like what we gave you a requirements, right? And then we're going to ask a simple question. Now that you know all of these things, tell me how you're gonna test your power. Right, so in order to put together a thing, that entire vision, you write the test plan. Now, as depending on the size of the project, like you may have only one developer or one quality assurance person, you may have multiple quality assurance people working on that particular effort or mission, right? You write a test plan not as an individual quality assurance person. You write a test plan one for your entire project or product, whatever you're building it. Right? It's the system that you're building it, and for that, you're writing the test plan. Right? So let's talk through the elements first, and then there's an example, we'll talk through that. So keep in mind, going out of the gate, nobody's expecting you to write the test plan right away. Right? But if you are working on a small project, you are the only person, then you will end up writing it. If it's a big project, you're just one of the many people contributing towards validating the system functionality and behavior, then whoever is taking the lead role in writing that entire quality assurance plan will be writing this test plan. Okay, so let's talk about it. What exactly and why do you even bother creating, right? So first one is you want to understand it is, what do I need to do it in order to test the systems, right? What are the tasks I'm going to perform? How many people will I need it? How much time I will need it? What tools I will need it, right? So you need all of those things. Okay. The whole purpose of that is to validate the acceptability of the software. And the reason why it's important, specifically the completion time and how many people I'll need it, because I need to budget it. I need to figure it out what it's going to cost me to validate or test thoroughly this system. Right? And that plan goes into, remember what we talked about in the planning phase, that it's an estimate of how long it's going to cost me to build the software, right? This is part of the cost to build the software. So you're providing an input and says how much it's going to cost you, what it's going to be. Okay. So what does it contain? Right? We talked about it, right? We need to think about it. What are my tasks, right? What is in scope? What is out of scope? What is the work or periphery that I will do it? Right? Because just like you go into a home building, right? And somebody wants to put a house, you talk with a contractor, right? You always define the scope. What is your scope? You're going to do everything, or you're going to do only certain part, and then I'm going to have somebody else do it. Like, for example, if you're building a single story house with a patio in the back, right? Typically, the contractor will tell us, okay, is patio part of the contract? Or I'm going to build a house and then add a patio later by somebody else, right? That's nothing but a scope. Like, same thing in this one, the scope. Am I going to test everything? Or I'm going to test it only whether it's fit for the purpose? And there are certain things that we talk about it. We'll talk a little bit later, what we call is load and performance testing, the sanity testing, the failure testing. Do I do all of that? Or I just say, is the system working as per the requirements or not? Okay. Then it also talks about the approach, how I'm going to go about it. Remember, we talked about just even software development methodology, right? There are 3 different types: agile, waterfall, RUP. Right, that's 3 different ways of going to do it. In testing, what is the approach I'm going to do it? I'm going to write everything and then going to test it, or I'm going to write few things, test it, write few things, test it. Like, it's how I'm involved, right? How many people I will need it? What will be the timeline that I will do that? It also starts identifying at a high level, what are the feature, right? Goes back to the scope, right? If I'm doing functional, non-functional, both, even within a functional, am I doing everything or I'm testing only certain features? What are the tasks? What is the allotment? More important thing, it also identify what are the risks that requires the contingency plan. Okay. So if you think about it in that V, It's great, you can writing all the test plan, but can you execute any one of that till actually software is delivered? You can't, right? That's a big risk. If you talk to project team and says, hey, I'm gonna give you software this time, and then you have 3 weeks to do the testing, right? To do that execution arm, to do that. Now, if you come through it and say, hey, developer, it's gonna give me this date, you need 3 weeks, so I'm gonna put it to commitment to the client that will deliver software in this date. Great. What happens if the software development team does not deliver you code? Till only 1 week is left. Right? Now you have 3 weeks worth of work. Are you gonna cramp it into 1 week? Right? You have to figure it out what plan, what the risk is, right? You can say, hey, you know what, there are one of the two choices. I can still do it 1 week, but instead of doing all the testing, I'll do only this part of the testing. And then you'll have to take a risk with a not fully tested software deployed in production. Or the other alternate option, you could say, if that happens, right, instead of 5 people that I was anticipating to do the testing, we need to add 15 people in order for us to meet that timeline. Is it possible? I don't know, right? Depending on the risk and depending on the dependency on the projects and depending on the work, you can possibly do that, right? Or the third option is, you know what, we need to shift the timeline, add a 2 weeks and tell the customer, you're not gonna get this date, it's gonna take 2 more weeks. Right? So you can identify all the risk and says, hey, what are potential options that we need to think about those as we go through it? Then it talks about the tools. Well, what exactly am I going to use it to test the software? Right? And the important part is deliverables. As I go through it, what will I deliver that gives you a really understanding of how the effort is progressing? Right? So, for example, your testing reports. How many test cases I've written versus how many have executed it? Am I on track to meet it? Okay. It refers to a whole bunch of things, right? The templates, what are the standard ways we do it? But more importantly, it identifies what are the related documents, what version of the software requirements document I'm using and what version of the design document. So there's a baseline. Anything changes to those versions, needs to do it, I need to reevaluate to make sure I understand what the impact will be. Okay. It also contains a different aspects of it is, hey, how many scenarios I'm going to write it, what high-level test cases. Okay. So scenarios are essentially a hypothetical situation that is identified to a test function or functions of the software together. Right. So for example, right, we can think about a test scenario as, hey, a credit application is created on behalf of customer, went through the whole cycle and got rejected. What is, I need to test it in order to do that scenario. Another scenario is the customer comes in, I create a credit applications, right? The dealer approves it. How is the whole thing works in? What scenario comes in, right? The third one is I'm a our loan rep trying to go to the dealer, get them signed up. Remember the process that we talked about? If I execute that process, that's one scenario. Okay. Underneath that scenario may have many test cases, right? So for example, creating a credit application, right? You can think about tons of the scenarios that you need to test it, right? For example, primary applicant, secondary applicant, and so on, right? Going back to the text example that I talked about, right? One scenario is like, it's, hey, I want to file a single return, right? As an individual. The test case is based, okay, as an individual, you want to file, it's great. Do you want to do a standardized? Do you want to do itemized? What type of things you want to do it? Within that standard, is it like you doing it 1040 easy, which is simple form, or you want to do an extended form, right? It's a high level scenario. talks about the situation. Test cases talks about one slice in that situation that you specifically going to test. Then there are test scripts. So as you go through it, remember I said step-by-step instructions. Going back to cooking example, if I want to cook a pasta, I need to write the recipe step by step, do this, do this, do this, right? Nothing but a test script. If I want to write this or validate this test case, what is step-by-step instructions? I'm going to do it. How I'm going to bring multiple test cases together in a script to test the scenario. Right. Then, yes,
So is it test scenario, is test condition?
you can say it also test condition, but depending on the granularity of the condition that you define, you can say it's here or it's going to be here. Like, think about it as a capability that you're trying to do it, scenario is. That capability may have multiple things that you need to test it in order to bring all the entire picture together. That's test cases. Okay. As we go through it, we'll talk through all those things tomorrow. Right? We'll take this example one here. We'll start drilling it down there. We'll go through this test scripts with that. Then the other aspects that your test plan contains is the metrics. Okay. And there are two types of metrics. One is the product metrics, and the other one is process metrics. Okay. So if you think about it, when I'm doing a testing, right, I'm testing on a specific software, right? Specific, like Rflow, that is what I'm building, right? So anything that I produce it, which tells about the quality of the product or quality of the Rflow process itself, is essentially a product metric. Anything I do it in order to do my entire testing, right? From a acceptance test to a system test to a link test to unit test, right? The entire lineage is nothing but a process that I'm following. Any metrics around that process is also captured into the test plan. So for example, right, we can just say a example of product metrics is I've tested 500 test cases and it covered 8 functions. Okay, so it tells me how many functions I've kind of covered as part of that. So that's a product specific, right? The other process aspect is I've created 500 test cases, but I can execute only 10 test cases a day. So in order to test that 500 test cases, and I can do only 10, I need a 50 days worth of testing cycle in order to do that testing. That's a process, right? It's nothing to do with the product. It doesn't matter how many products I'm testing it, how many functions I'm testing it. All I'm saying is my capacity is only due to 10 tests a day. Right? That's a process, that's right. When you look at the test case, going into deeper into the test case itself. Remember, I said, at the end of the day, software is nothing but providing an input, performing some computation on those inputs, and creating an output. Right? So if I'm trying to write anything that essentially validates whether things is working or not, I need to think about what is my input going to be. Right? But when I apply those input, I need to understand what is the state of that process is going to be, right? So for example, if I'm doing a mathematical addition on a calculator, right? If I'm doing 2 plus 2, right? I need to know, is that 2 plus 2 I'm doing it as part of a fresh new sum, or it's part of ongoing calculation where I'm adding this 2 plus 2, right? So I need to know the state in which the system is, and what are the input? What is the state, right? And based on that, I should know what is the expected output. What is my behavior? And that behavior maybe is, hey, if you provide in a calculator, if you're doing it addition, right? I need an input, whatever the state is. But if I'm doing a division, right? As long as you provide me a number, I'll still get a number. But if you provide me a 0, my expected behavior is to get an error message saying that you can't divide it by 0. Right? So your expected behavior could be a false scenario or error condition that you're anticipating based on input and state, or it could be what is sometimes we call it a happy path. Is everything working? Everything is within the bounds. So this is the result. Should I get it? Okay. Unhappy path are essentially anything that goes outside the bounds of normal, right? So division divided by 0 is essentially going to result in unhappy path, right? A behavior of a good test case, right? We already talked about, hey, better be written in such a way that you have a high probability of finding the defect, right? But more important is the bottom 2. It should give you clear and unambiguous results. So if I run the test case, I was looking for a certain condition, right? And it says, I gave the input, I know what is the condition, right? When I get the results, can I compare with the expected behavior and simply say it matched or it didn't match? If I can simply say yes or no, then I know it provided unambiguous results. But if I get unexpected results and if there is a gray area, did it match? Probably, I'm not sure. Then there is a problem, right? Because then you're not getting an unambiguous results. As a thing of that, you don't know whether it passed or failed. You don't know whether the system is working as expected or not. Right. So whenever you write the test case, make sure whenever the test case finishes, you should be clearly able to say, did it pass or did it fail? Okay. Other aspects, it should be repeatable and predictable. By repeatable, what it means is, can I run it over and over again? Right, so if I give the same input, and if this system is set the same way, can I run it again and get the output that is my expected behavior? Okay. The predictable aspect is, if I run it with the same input, same state of the system, will I get the same answer every time? Whether it's right or wrong, did I get the same answer every time? As long as the first 2 conditions are exact same, this one should be exact same because I should be able to predict it. Right? If I ran once, it passed. If I ran it again, it failed. That's not predictable. Right? So that's the aspect that you need to think about. For example, right? If I'm turning this switch on off, right, that's the test. And I know if it is the lights was off and I turned it turned on. Second time I do the same operation, if it doesn't turn on, right? That's not predictable. I can't predict it. If I flip that switch, it will always turn on or off the lights. Okay? That's the aspects in the system. So whenever you write test case, you need to think of those 3 things. Now, one of the other aspects in the test plan talks about is what is the standards you're using. Okay. Part of the computer writing software is, that's why it's called a computer science. Okay. So whenever you think about the computer world, right, you will hear 2 terms, computer engineering and computer science. Okay. Engineering almost think of it as a hardware. Okay. It is kind of precise standards, right? So when you create a CPU or a memory, or when you connect it to the all the different layers of the memory that we talked about, that is exact same way it's science of how you connect it all. It's all engineering. It is all precise in that. When you write the software, it's a science. It's an experiment, right? As you write the code, just like you go to the, as much as it sounds scary, right? When you go to a doctor, right? They talk about medical as a science. Nobody calls medical engineering, right? Everything medical engineering is with the devices that they build it, not with the diagnosing people and treating the people. That's all called science. Because it's all hypothesis. If I write this software, this is the output I will get it. If I give them this medicine, this is the expected behavior I will see it in the patient. Right? So typically science are things where you cannot set the standards. You can set only the guidelines. Right? Software testing is one of those times. You cannot say it's, hey, every system that is web-based, if I write and execute this 5 test cases, I'll get the results whether it's working or not. Right? Think of it. If you're writing a software, which could still be a web-based software, but to do it a banking application, the test plan for that is going to be different than if I write an application to purchase something like Amazon. Right? So that's why you can't build a standard and says everybody must follow the standard. What it is most likely you identify the process, you identify the templates, and then you put the techniques that you have. So if you look at it, this model, this is nothing but a process. It's giving you templates. If I have this sets of information, here is the type of test I can write. If I have this type of details, here the type of test I can write. Right? It's all process intended. So your test plan is going to talk about, here is the template that you're going to use it to build the test cases. Here is the template that you're going to use it to report how successful metrics are, whether the test is successful or not. Here are the techniques that you're going to use it in order to perform the unit testing versus acceptance testing. Okay. Then it also, the test plan also talks about the environment. Okay. So let's talk for a moment about environment. Okay. And we will start with the production environment. Okay. Production environment is typically where your actual software runs with the live customers. Okay. So let's say I'm writing a banking software. Okay. What is a production environment? It means where actual customers are interacting, they're actually depositing, taking out the money, withdrawing from ATM, writing the checks, so on, right? This is where actually all the information about what is the balance of my accounts, what are products I have, right? What are the services I'm consuming from the bank? That's a real production environment. Right? Customers paying it, the actual money transaction. So that's a production environment. Then going all the way to the left on the development environment. When somebody's building a software, let's say to transfer money from one account to another account, let's take that feature that I'm building. Right? They may be writing a software to do it. It's not perfect, right? Because as they're learning it, there's going to be defects, right? There may be a work that they're trying to do it. So they may be constantly changing the software. They may be learning something, fixing it, retesting it, type of things, right? The developers are doing it. Can they do it here? What will be the impact?
Customers will get impacted.
Customers will get impacted so much, right? To the point is, hey, customer think, hey, I can transfer the money. Good, I want to transfer from one account to another account. Well, the piece is working only to take the money from one account and have the piece that deposits in the other account isn't working. Will they be happy here? You don't want to touch that, right? So you want to do it, all of the development in one place. Sometimes that environment is also called as a sandbox environment, right? So think about it like it's when you observe it. Let's say you go on a beach, right? You're trying to build something, right? You're trying to like it's do something, doesn't work. What do? You destroy it, right? Rebuild it. You keep doing that till you're satisfied with whatever you're building, right? That's why the term, the sandbox comes in. It's an environment where I'm bringing it and breaking it, bringing and breaking it. Okay. That's my individual sandbox. Now, if you think about it in a big project, there won't be only one developer, right? There will be many developers. And they will be working together. One will be says, hey, you know what? I'm gonna go out and build a functionality that allows you to take the money from one account, which is the withdraw functionality. Somebody says, I'm gonna work on a deposit functionality, which takes the money, adds to it, right? And the third developer says, you know what? I'm gonna bring those two together. Because a transfer is nothing but withdrawing from one account and depositing into the other account. Right? They all three could be working differently in their own sandbox to see if their pieces work. But once each individual pieces works, they're going to bring it back and say, does it work together now as a single piece? Right? It's still doing a development, right? If they find it something, they'll go fix it and do that. Right? So a lot of times you will hear the word like sandbox for individuals or area where they experiment, and the development environment is where they bring the things that is working together to see if it works as a one piece or not. Okay. Typically, developers are playing in that area because they are constantly building and taking it out. If you are a quality assurance person, right, and you are tasked to do the testing to make sure the system works as expected, right? What is the risk of doing in this environment? It's constantly changing, right? So go back to the test cases we talked about. Can I predict it? And can I repeat it? If my code is constantly changing, and if I'm running a test, can I guarantee it's a predictable and repeatable? I cannot, right? Things that is working in the morning may not work in the afternoon, and vice versa, right? So this one is too much unstable environment for me to execute my tests, right? So as a tester, you try to stay away from that environment. The other environment is production, right? If I test it, things change in production. Is my customer going to like it? Right? Because I'm actually impacting the live data. I'll give you an example. I was working in a telecom firm for 20 years. So it's part of a group which was kind of like it's working and interacting with the teams or building a software that goes on a live network. Right? We had a tester who accidentally pointed and says, you know what, this data is there, I can grab it from production, because what we are trying to figure it out is as the customer leave, those circuits were still provisioned to carry the traffic from one point to another point. We said, okay, we need a cleanup because we can't just keep building new switches and new routes. Anybody who is not using anymore, we need to reclaim it so that we can resell it or redeploy it for the new customers. Right? Great idea. Build that, look into the live switches, right, and says, can we do this test? Can we now run it? We know how to identify the live customers as dead switches or the ports which are empty. We can do it. Can we do a cleanup? Because you definitely don't want to carry a data because you got to wipe that data in order to provision new data. Somebody accidentally pointed into production and ran that script. Okay, what happened? It wiped out entire paying customers live in the middle of the day. Okay, things like CNN and everything was brought down because now they can't carry the traffic from one point to another. That's an impact, right? To customers. Think about it, the amount of the work ends up. You not only messed up the production, some live data. Thank God it was no 911 traffic or the traffic that essentially allowed the hospitals to carry the surgery across the continent through the videos. If it would have that, think about it, it's a human life cost, right? But we had to restore everything back, make sure everything works. There is a reputational loss, there is a financial loss, right? Just because somebody pointed wrong, right? So as a tester, you want to eliminate as much possibility as trying to touch anything in production. There may be a case where say, hey, I'm only reading the data, I'm not changing the data. That could be a gray area where you can say, oh, we can think about it. Right? Going back in development environment, if you cannot keep doing things over and over again, and still not sure whether it's going to work or not, why even waste an effort? Right? So you cannot work on that environment, that you need what is your own dedicated environment, where you know the software is stable, it's not impacting the live customers, but it has the similar characteristics from the production and from the development, both the new software, existing software, because you're not working in isolation, you might be working with other softwares or other environment. So you need to make it sure, right? So you build a lot of times a dedicated test environment. Now, if it's a small company, don't have a lot of machines, you can just say, hey, you know what, from this time to this time, we're going to do development. And then we're going to time slice in the night, there will be always testing. So you don't make any changes. You just let them do the testing, right? Within the testing, there are different types of testing. Remember the V from the top to the bottom, right? You may have a UAT testing, right? You may have a system testing. You may have integration testing. A lot of times you do it end-to-end testing, right? Because in a complex ecosystem, you are not working as a standalone software system. You're working it with the other systems. Like, for example, when we talked about the Amazon, right? I'm purchasing a book, right? That requires me inventory system, which tells me whether the book is there or not, right? Then it requires me the financial systems, right? Whether I can charge the customer for this book or not. Then there is a shipping system that I'm interacting with it. When I ship it, that can I track it or not, right? So there are multiple systems that are working cohesive. So whenever I'm making a change to, let's say, inventory system, and I want to bring it to test it, I need to make sure it works well with the other systems together. That's the end-to-end environment that's trying to do everything. The other aspect is load and performance. Remember the example that I gave you, it's Black Friday, 100 million customer comes in. Is my system still going to perform under that load the same way? Or is it going to crawl to a halt where everything takes like 5 seconds and whenever I click it to get response, right? We all have seen that, right? On certain days, certain time, if there is too much expected, things come to halt. Because the system load is essentially more than what is it built or designed for the performance. Okay. So these are the three environments that you talk about it. In test plan, you identify whether this environment is dedicated, what do you need it, how many environments you need it to perform your testing. So those are the level of detail. Any questions on the environment?
What is UAT stands?
Huh?
UAT stands for?
User acceptance testing.
I have another question. Can the development and test environment have same database? Or they need different one?
So when you say database, there are logical and there are physical partitions, right? So there are a lot of different architectural ways you can do it. But from a testing point of view, and think about it. I cannot mingle the data from here to the here. Why? Because remember, if they change here and I don't have control over what they changed it, can I predict my test cases? Cannot, right? So think about it. It's logically, can I isolate this thing? Right? Physically, it may be on the same machine. I don't care. Logically, can I isolate this thing so that any changes I do it doesn't impact the development and vice versa? Then sure. Right. Any other questions?
The developer only can do the production, or like customer also can, at the end, if everything is works fine, of customer complete in production or development?
So depending on the size of the company, you have a different people performing different roles. Okay, if I'm a small company, it's only 2 or 3 people who are in my IT staff or developer, they will probably manage and deploy everything. If you're a big company, like it's kind of nationwide or JP Morgan, right? We have a dedicated team which kind of focuses on separating these environments then they are the only one who does it, right? So there are also regulated requirements that if I'm an individual, I cannot access test environment and a production environment at the same time. There are dedicated people who are responsible to take the code from here, move it here. There's a whole bunch of restriction. These people cannot see the production data. Right, so like if there's HIPAA compliant, there's financial regulation and everything is involved, right? So developer always works with the dummy data and they rarely have access to the production.
So in,
Go ahead, and we'll talk.
So I heard sometimes we are going online, we are going for live testing. Who are the person responsible for doing the live testing? Is like a tester or like?
Depends, right? So when they talk about live testing, all they're talking about the UAT and extending UAT, right? So depending on the firm, they just say, hey, we're gonna do the UAT in a test environment. But then they also have a way to isolate. We're gonna deploy this thing into production, but not everybody is gonna access it. Only certain people are gonna access it. Right? So we do that often. Right now, I'm working on a project which is going to be massive transformation. It's going to impact eventually everybody in the JP Morgan of how they work and how they behave. Right? We said, okay, we are going to build it. We're going to test it, everything. But we are not going to shift it completely for everybody on day one, because we need to learn what their behavior is. Is it helping them? It's not helping them. We need to measure it as what the level of effectiveness it's helping them, right? So we will probably put into production, but make sure only certain segment can see this new. All the other ones still exist the normal. Once we figure it out, then we slowly broaden the impact, right? That you can do that. Right? So when you talk about live testing, depends on what people say. Some people talk about live testing is, I'm going to have all of the environments available and do that testing, just like what has happened on the real world. Versus some says, I'm going to take that and actually going to deploy it for a small population of the actual my users and do that. You will hear a lot of times, right? That, hey, this feature or capabilities are like it's enabled for only this sets of users. That's nothing but that.
so, in production, who maintains the functionalities?
So there are dedicated teams which are responsible to keep the production environment up and running all the time. Right. So it's again goes back to how big is your company. Right? If you're a small mom and pop company and it doesn't have a big IT staff and doesn't have 24/7, then sure, production can be maintained by the same people who have maintained their interest. Big companies, that is a dedicated. Specifically when there are concerns about HIPAA regulations, financial regulations, then there are rules that you have to keep this people separate from this people. Any questions online?
So as a tester, do you create your own environment based off of, let's say you're the end user? Is that what it is?
So I want to mindful. You access your own environment, but not necessarily if there are 5 testers, each one of them will have their own test environment. It's still a single test environment accessed by multiple testers, but it is separate from a dev environment or production environment. Does that answer your question?
Not really. So I know, for example, like you're saying, if it's a small mop and pop company, then probably you'll be on a different environment base depending on what you have to do. So I'm asking, do you create your own environment as a tester, like an end user? Is that your own point of view? That's what I'm trying to ask.
Yeah, so as a tester, you don't create your own environment. There is a common shared test environment that all of the test team uses it for that particular application. Now, depending on from one project to another project, you may create a separate environment for the testing. But as long as you're working it on the same project, and you're trying to perform the similar functionality, like for example, system test, you're gonna keep it the same environment.
Okay.
Now, there are very complex ways that people can do it also. But I don't think you're gonna interact into that. This ends up when you're trying to do a high computing environment where essentially you have 24/7 and you cannot afford it to bring things down in production to upload it. Like it's as you look into the cloud, there is a live deployment, essentially. We don't have to worry about that complexity. When you get started, think about 3 separate environments, and you're gonna focus in the test environment to do your testing.
So coming out with a test plan, like you said, there's no fixed way of doing it. It's like guidelines. So when coming out with a test plan, do you just go by the guidelines and say, okay, based off of the requirements, I'll use this tool to do this, I'll use this tool to do this, but you're not, since the product is not yet there, so you don't really know what you are. So are you going by the guidelines? Yeah.
Yeah, so guidelines are essentially, think about it's a guardrail, right? So let's take an example. Okay, when you're driving on the freeway, right, there are guidelines, right? There is a speed limit, there are lanes, right? As well as there's a directional, right? So if I'm going northbound, there are 4 lanes, then there are still each one of them. And there are guidelines, right? The guidelines is, hey, if you're driving fast and you're trying to do it, stay in the left lane. You're trying on the right lane, right? And if you want to overtake somebody, you go in left lane and take it. Those are guidelines. Does people drive the same way? They don't, right? But do they still have to follow? Like, for example, can I drive it southbound on a northbound way? No, right? So it's a similar thing. There are guidelines which says that, hey, you need to do this kind of testing. Here are the tools that you use it to do that. Now, how you actually use it at the runtime may vary for a little bit from one developer or one tester to another tester, or from one project to another project. It may vary a little bit, but it is still within the guardrail. Like, hey, we're going to write all of the test cases in this template. Now, how many test cases you write it, it's going to be dependent from one project to another project. That's what I was talking about, the guideline versus standard. Does it make?
Yes, it does. Oh.
Any other questions?
It is mandatory that the developer has to give the code to the tester, or developer can test, or he can put it in the production.
So again, think about this as a guideline. Okay. What it goes it from a developer should write the test environment, should be tested here before migrated into the higher environment.
No, I'm asking like whether the tester has to be tested or developer can test it. If I'm writing the code, I can test it and put it in the production.
Depends how big is the company and what it is, right? And I'll tell you, like it's, and this is something that you don't ever do it, like it's, but you, this is where you learn it. I have written the code in production, tested it and deployed it. Okay, is that the way I would do it? No. Right, I've seen people accident says, hey, it's a small thing, let me just go and fix it in production and wipe out the entire production databases. Okay, that's when the people put in is, depends how critical is this system. Right. Again, when you get out the gate, one thing I want you to think about it, separation of environment. Now, depending on how many people are in the team, you may have one person managing both. You may have one person managing all 3, or you may have 10 people managing this, 10 people managing this, and 50 people managing this. That's a different thing. From a logical isolation, developer putting code into production is me driving it on a northbound lane and a southbound. Can I do it? Yeah. Am I stupid? Probably yes at that point. Can I going to run into accidents? It's a highly probability. Do I want to do it? I don't want to do it. Right? Same way. Because there is an impact to the customers, impact to the company, that's what it is. Can you do it? Sure. Nobody's gonna prevent you, but there are rules put it into the different organization to make sure you don't do that. Because there is an impact, right? So for example, as I say, if you're doing a 911 system, you bring it down because you were not smart enough to do the development environment. You did in production and somebody loses life. Now your company is liable, you are liable for those. Do you want to do it? Probably not. Right? The point is, forget about the liability point of view. From a simple predictability point of view and repeatability point of view, if you do in any one of this environment, you cannot get into those things. And in order to validate, is the system working as expected or not? You need to have those characteristics. And that's the only thing you can get it here. That's why you should focus on doing it in this one. Occasionally, you may go and access system here or here. That's a very case by case basis. Right? But as a developer or as a quality assurance person, anytime anybody says that, hey, yeah, we'll do it, we are building it, why don't you do this so we can cut it? My first answer is always going to be no.
Oh.
Because it's the value that I get in this environment, you're not getting here and that. Because if they tested something and I tested here, it worked it and they made some changes after that and deployed it to production. Now I'm putting something that is.
Teacher, why is like kind of
I have one.
Yes,
So if the tester finds it's not working or something like bug, he finds a bug, he'll report it like kind of report, like how will you report back to the development?
so there is a defect tracking tool, we'll talk about it, right? So they identify the developer actually work in that environment, changing the code, and they give you actually new version of software. That's what then you retest it.
Okay.
Developer doesn't come here and fix it here. They actually give, here is the new piece of software, you redo the testing. And we'll talk through those testing scenarios in a moment. Okay. Any other questions?
So basically what you're saying is that, when the developer sends it to the taster, they cannot change it unless if the taster finds a bug and sends it back to the.
Right. So there is always, think of it, there are copies. And everybody's working on their own copy. Once a developer gives a tester, here's the working version ready for test, they give you a copy. And you test on that copy of the software. They can change their own version, but it's not impacting you because you have your own copy now. You identify the issue, you tell them the issue. They take on their own copy, reproduce that problem, fix it, change the code, give you a new copy, and then you work on it.
I have a question.
Yes.
So when the software goes to, when the developer started and then the tester do his job and then the user found out that something is not working right, are they gonna start the process over? We start with the.
Yeah, who is fixing it? These guys are fixing it. So they need to start working here. Once they fix it, they give it to you. You try to recreate the issue that user reported, make sure it's fixed. Once you're satisfied, once it gets ready for acceptance, that time you go and put it in production.
So is the testing done simultaneously? So developers do their own testing while you do your own testing, and if something does not work, you guys communicate back and forth based
So-
off of.
Hold on to that question till we go different types of testing. There are certain testing that the developers do it, and there are certain testing the testers do it,
Okay.
but it is not simultaneous. Okay, and we'll talk through it. Think about it, right? If a small piece of Lego is not working, can you build a tower from that Lego? You cannot. Right? You need to first make sure that small piece is working correctly before you give it to the person who is assembling the tower. Okay,
I have
Okay.
okay. Another question?
The production, there is no testing at all. Nothing. How am I going to make sure?
Okay, I think we are
It's going to work.
digressing into the different scenarios,
Mhm.
which a lot of that thing you will come through it as we go through. Here's the
Okay.
key thing, and I want you to take it from this slide. Developer have their own sandbox where they're constantly making changes. And then proving certain functionality. As a tester, you should stay focused in the test environment on a version of software that is given to you, right? So every time this green arrow comes in, it's not as simple as, hey, I'm done and here is throw over the fence. There are specific processes and specific way that you hand off the softwares, goes from one environment to another environment and deploy it. There are certain testing criteria, there are certain inspection things which is in place. Can it be automated? Yes, but there is a specific way that you take it and copy from one environment and migrate it to the other environment. And there are rules that has to be turned on before you can get into a different environment. Okay, we'll talk about it as you go through it. Again, software development is a science. There is always a variation going to be, right? The best practice is you stick in your test environment to do the testing for the high chance of successful and high chance of repeatability and confidence. Anytime you go outside that bound, your confidence level of everything works as expected, you cannot guarantee it. Okay. And as we go through it, you will see it as we talk about different tests, what and why it's an important, and as you get your hands onto the real world, you will see it, the pattern, why you don't want to do certain things. Okay. Another aspect of the test plan is the test data. Right. So for example, if I'm doing an R-flow testing, and I said, I want to create a credit application, well, what data I'm going to use it to create the credit application? Who comes up with data? How do I get access to that data? That's all needs to be talked about. Within the data, there is going to be positive test cases, as I talked about, and there will be negative test cases. Right. So all of the data management is identified also in test plan. How are you going to get about creating or getting access to the data that will be used to test your system? Okay. And obviously, how are you going to execute the test, right? So have you designed what data you will use it? How are you going to execute it? Manually, automated way? What engine, what tool you're going to use it? Then you talk about how you're going to conduct those things, right? So if it is a manual testing, it's a testing which requires a human touch or human intervention to do anything. Automated testing is essentially it gets run on a predetermined event based, whether it's a nightly timely batch or when certain things happen, it triggers those testing. And then you don't need a human to intervene and do that. Okay. So most of the modern day, right? You do the manual testing, you automate it, and then every night there is a huge regression testing happens on behind the scene, which tests everything to make sure nobody broke the code by doing something and during the day on anything. Right. Also, when you remember what I talked about, going from one environment to other environment is a lot more stricter, right? So if I'm a developer, I build something, I can't just say, here is the code, right? That it's an automated testing or certain sets of manual testing. They need to execute it, show it it's still working before handing it off to the next environment. So all those things happens at the behind the scene. Okay. Then we talked about the metrics, right? Process metrics and product metrics. One of the key metrics is test velocity. It's essentially telling you how quickly and at what pace you are testing it, right? Velocity is nothing but a speed over time, right? That's what this is. How many test cases I'm running in 24 hours on a weekly basis, so I can predict it. Am I going to meet my timeline or not? Okay. And as you go through the testing, right, you're going to build reports. So that's what you identify in test plan. What kind of reports you will be producing it, and how frequently and who all will be accessing, right? So you may just say, how is my testing is progressing? Well, I predicted, initially estimated that it was going to be 200 test cases to test this system. I've done only 10 test cases. So that means I'm done only like 5%. How long it's going to take me to finish through 100%? What is the quality of software being produced? So another report could be is how many bugs I'm finding whenever I run the test cases. Right? If 50% of my test cases are identifying bug and failing it to meet the expected behavior, that means there's a lot of rework needs to be done. Those needs to be fixed, those needs to be retested, right? Versus, hey, I tested 200 and only one test case had a problem. Indication of one of the two things. Either I wrote very poor test cases that failed to identify the bugs, or second is software is very good and it's almost ready for the prime time, right? That gives me a quality of software, gives me, can I deliver things on a committed time or not? Okay. Some of the other reports you can think about it is there are multiple functions, right? When you look into our flow, it's broken down into 6-7 different functions, right? As you're testing it, you can say, hey, managing dealer functionality works fine then. Focus on creating credit application, right? So you show it over the timeline, which functions has been working it, right? Obviously, we talked about defects, right? How many were identified versus how frequently developers are fixing it and giving it a turnaround. How long it's been lasting. If it's taking an average of 10 days to fix a defect, I can predict it as, hey, it's going to take me this much time to do the software testing completely. How defect is distributed across different components. So it gives me an idea. One part of the system, it's built by this group, it's not working as expected. So they need a help in terms of quality, in terms of implementation and so on. Obviously, the functional testing, right? Simple, yes, no, working, no. Did I test it? Yes. Is it working expected? Yes or no? Some of, again, all of those things, right? The defect distribution, average age, how it's kind of distributed. Then it also identifies the scale we're going to use it as we find the problem with that. Okay. And typically there are two scales. One is the priority scale, another one is severity scale. Okay. The severity scale essentially talks at is what is the impact of this test or a defect that it's identified. Okay. Is it very critical to the cosmetic? So for example, let's say if I'm creating a credit application and one of the key component is social security number, right? You need to know social security number before applying for any loan or anything. If my system is not allowing me to enter the social security number, that's a critical, right? Because I can't build an credit application to do that. Versus if my system, I identify a bug where it says, you know what, the social security number, there is asterisk which is required as kind of missing in it. It's a cosmetic, right? It's still there. And if they don't enter it, it's going to prompt you with the error that you must enter social security number. But it was not a visual indicator to begin with that. Can I go live with that? Probably yes, right? Without impacting it. But I cannot go live with the predicament. Right? So every time you identify the defect, you identify what is the severity. Is it really critical to the system functionality? Or is it something which is cosmetic or somewhere in between? Okay. The other one is priority. It's essentially a measure shows how important is the defect. Right? So one is the impact level. And the other one is importance level. Okay. And then typically this is a high, medium, low type of things. High is something that, you know what, it is critical. I needed to get it fixed. As soon as, without that, I cannot release it. The low is, yes, I know it's a problem, but it's not as important for this functionality. We can still live with it. We can go with live with that. Right. So categorize. So the combination of those two helps you to identify which defects I need to fix first versus what defects I can wait it to get some additional time for the developer to do it, right? So it also helps the developer if there are 100 defects identified, which one I need to fix first? If a tester comes in and says, developer fixed 100 defects, which one I need to test it first? Okay. Then it goes around the metrics that we talked about. Right, the product metrics, which measures the effectiveness of the software or the system you're building it. And the process metric, which essentially measures the effectiveness of the process you're using it to test it. Okay, and here are some examples of those metrics, right? One of the process metrics that you can use it is how long it takes it for you to identify a defect, right? How many test cases you have to run it on an average before you identify a defect. Versus the other one, it just says, once product specific is once the defect is identified, how long it takes you to, what is the cost to fix that defect? How long it takes it, how many people needs to be involved and so on, right? That's a product specific thing. Here are some of the test tools. Okay, now we'll look at some of these test tools as well as some of those, like we started shifting into more modern cloud-based tools. So we'll use additional tools on top of this thing. Okay. So one of the homework item for you is on the third tab, there is a third document called test plan. It's in the tab after you finish reviewing the detailed design and specification document. There is a test plan document. So as a homework, I would like all of you to read that. Not by tomorrow morning. Read it by Thursday. If you have any questions, we can talk through it. But that will give you an idea of what the test plan will look like. Yeah.
They have a separate document.
Right.
Where it is?
So for online, remember you went to the folder where there were multiple documents. One was the requirements document, one was the detailed design specification document. In that folder, there is a third document called test plan. Okay, it's a third tab. It's in the tab after you finish reading your design and requirements document.
It's after system design document.
Yeah, if you had a physical copy of folder, it is after system design document.
Okay, yeah.
Okay, if you are accessing virtually, it's in the same folder. It's a third document called test plan document.
Yeah, I got it.
Okay. Okay. Right. So let's take it's a 10:30. Let's take a 10-minute break. All right, and we'll start back at 10:40. Let's just stretch the legs, and then we'll start getting into a little bit more detail in terms of estimation and getting into the specific different types of tests. Okay. So online, we're going to take a 10-minute break. All right, let's get started. So we talked about the test plans. So one of the other activities, as you go through it, we talked about things that the test plan contains, right? But at the end of the day, you also have to answer one simple question: how long it's going to take you to test this software, right? So they give you a requirement and then ask you to come up with an estimate. And that will be true irrespective of whether you're doing the entire test plan, an entire testing effort by yourself, or it is involved like 10 testers, let's say, or 10 quality assurance people, right? They will just give you, okay, here is the module that you're responsible for it. Tell me how long it will take it and how many test cases, right? So there is a specific process that you go through it. And what I'm going to do is let's start with a simple question, right? So let me see if I have a whiteboard yet. Okay. So if I may ask you to just get a guesstimate, you all read the requirements document, right? For our flow. Okay. If I come back and ask you, okay, how long it will take you to test it? give me a number of days. How much time it'll take you to test that entire system. Knowing that you're going through entire STLC life cycle, remember the one that we talked about today? How many days would you answer?
So one resource also.
If I says you are the only person who's gonna do it, right? How many days do you think you will take it? Well, you have to answer, right? Because they're giving you software, right? So it's kind of like if you go to a contractor and says, okay, how long, here's the house that I expect you to build it. How many days do you think it'll take it? And if a contractor says, I don't know, will you hire that contractor? Right? At the end of the day, they're gonna pay your salary or check or contract, whatever you're doing it. They better know it, what exactly you're gonna charge them, right? If you don't know exact number, but they will like it, what is the estimate? Give me, is it 3-day work? Is it 5-day work? Is it 50-day work? It's 500-day work? What is it?
So there will be a difference between manual and automation. It
So,
doesn't matter.
Forget manual automation. I have simple questions. I gave you a system requirements document. And if I ask you, you are responsible to test it, how many days you will take it? A month is 30 days? 20 days? Okay, 30 days. Okay. So one answer is 30 days. Anybody more or less? Anybody online? How many days do you think you will take it? Jeez, everybody is consistent. This has never happened in this meeting. That everybody says 30 days.
30 days or more.
Yeah, I think
Again,
Yes, sir.
will you hire a contractor if it says 30 days or more? What does more means?
Let's say 45.
I think 60.
90 days, I think, or more than 90 days.
Just realize that my next question is going to be, how did you come with that estimate? So don't throw only the numbers at me. Okay? So I heard it 30 days, 90 days, 60 days. Wonderful timings. How did you come up with that? Roger?
I mean, I just thought about the process I'm gonna go through, and
Let me ask it the question differently. Okay. So if I say it's whatever number you came up with it, and if that's it's great. Anything that you take it more days than that to test it. You're gonna do it for free, and there will be a penalty associated. That you're gonna pay me certain money because you didn't fulfill your obligation to finish the testing in 60 days. Would your answer change?
Yes.
Why?
Oh,
Why? Why financial penalty drove you to have a different answer?
don't wanna lose money.
So how many days you will think?
Well, then I'll have to bring it down to maybe 20 days.
You will bring it to 20 days?
20 days.
So you will go down.
I'll go down.
So from 60 to 45 days, you say that I'm gonna go change to 20 days.
But there are higher chances of you losing the money if you're not able to deliver it in 20 days, right?
Well, that goes back also to planning. I'm gonna come up with my plan and execute it.
Ah, you're gonna use some thought process before coming to estimate. What thought process?
How to differentiate the work, how to divide the work.
Right, so it's not thing that you pull the number out of the air.
How to divide.
A lot of people think you pull out number from the air. And that's when you get into trouble. Right? So you need to think through the process. And typically one of the processes, you go figure it out, hey, based on this requirement, how many test cases I feel that I need to do it. Right? And that some test cases are gonna be simple, some are gonna be complex. right? And then you say, it's okay, if I need to do that many test cases. How
So
many-
sir, I have a question. So how many test case we write? We have to test all those,
Yeah, you have to test all those functionality.
how many we write?
Yeah, you have to decide.
Okay,
The number of test cases I write to test the system, it's probably gonna be different than how many test cases Harshal writes.
So suppose if it's a very new system that's come out in the market and we don't have any prior experience with that, at least with the prior experience, you can kind of gauge the number of
Right.
days and everything.
So you-
how does it work?
So that's what you do through it, right? So here's the first step that you usually try to do it. Okay? It's again, there are multiple ways you can create the scope, right? You can create the scope by functionality. It says, here are the functions, the breakdown that is anticipated in the system. Here is how many test cases I need roughly to test this function. Here is how much time it's gonna do it. Or the other alternate you can do it is, hey, here are the like 10 different users gonna be using the systems. Site administrator, lender, dealer, R for R, right? So you can say it's categorized by site administrator and say, okay, for this particular user, what are the different scenarios I need to test? What functionality I need to test it? Okay. And then, is there any multiple sub-levels? What is the complexity involved, right? So for example, I can just say, hey, you know what? Site administrator have a whole bunch of capabilities. First thing, they should be able to log in into the system, right? That's a simple, it's a medium, right? It's a user ID password, right? There are different test scenarios I can do it. I can say it's one positive and one negative test case. Let's say I'm providing user ID and a password. And then I'm not providing the valid credentials. Two different tests, right? Then managing a dealer. Well, that is a little bit more complex than the login. It involves it in, I can break it down into, remember there's search for dealer functionality. So I need to test that. I need to test add a new dealer. May have to test to add or update in a new dealer or existing dealer. Right? I may have to go through a whole bunch of that. How many test cases I needed, a rough guesstimate, right? Because I understand the requirements. So I can say, hey, you know what, I need to test this requirement separately, or I can combine this two requirements into one test cases to test it. So you come up with a rough estimate of how many test cases you need. Right? So that gives you a view of how many test cases I'm going to build it. And as you go through it, right, credit application, it's a complex one. Right? I'll need a whole bunch of test cases to do that. Right? So you come up with some sort of a framework to guesstimate, right? And I said, guesstimate is till you start writing it, you don't know whether you're going to break it down further or not, right? But you can just roughly say, you know what, that's a one scenario, that's a multiple scenarios type of thing. So you can guesstimate and you can come up with a number of, simple, complex, medium test cases, you're going to write it for the system. So that's one factor. Then you go look into it and says, okay, when I look at my test plan, what are all the different types of activities I'm going to do? Right? What is the first activity you did? You read through the requirements document. Understood, right? That took some time. It didn't go like it didn't happen without that, right? So you start identifying, hey, what are the activities I'm going to do it? Roughly how much time it's going to take me, right? So for example, I need to understand what is the current environment. I'm going to allocate 4 hours. I'm going to meet with a couple of people, understand what it is. Then I'm going to do a requirement analysis. It's going to take me 3 days, right? Because I need to read it multiple times to understand it. If I have questions, I need to go ask people, get an answer, get that clarity. Then I need to build the test plan, right? Remember the document I said? I need also to put it up. I need to do some setup environment, right? There's dev environment, test environment. There needs to be an effort to set up. Is the data ready the way it is? I need to think around all the different test cases that I need to write it and build it. And how long it's going to take me, right? So you can divide those things into hours. And then you just say, hey, you know what? Total design effort, it's going to take me this many hours. Right? Then you say, okay, remember that is when you go to STLC. The first 2 was acceptance test cases and requirement analysis. I did those 2. Then plan and strategy. I added those. What is the next one? Execution, right? I need to think about execution. Well, how many times I'm going to execute? I need to think about it. What if there was a bug identified? I need to retest it, right? So I need to do all of those things. I can add that hour and says for that execution, then I'm going to just say it's, hey, then I will need a support, right? When users are testing, they will have questions. I may have to help it and show that, hey, I did this test, here's the results. So there needs to be some time for that. So you add all of that, and then you add a contingency factor, essentially. You know what? I don't get people's response in a timely manner. What I'm going to do it? If there are more defects found, how I'm going to deal with that, right? You add all of that, and then you come up with an estimate. This is how much total hours going to come. And in order to do that, then you divide it by essentially 8 to come up with, this is how many days I'm going to do it. Now remember, these are days, right? So you can't just say, hey, it's a 2 month and a week. No, these are 67 working days, which is usually Monday to Friday. So you figured it out that, right? So it requires about 13.5 weeks for me to do that. Right? So it's going to take me about 3 months to do the testing. End to end, involving all those activities. That's how you give the rough estimate.
Did you share this presentation?
But they're not able to see it? Oh. Sorry. Nobody spoke up. So they're not seeing it. All right. So maybe I missed it like it. So the first one we talked about is coming up with the users. And based on that, how many scenarios? Okay. And then we'll have this data accessible to you also in the folder. Once I get an estimate of how many test cases I need, I'm going to go ahead and say, what are the different activities I need to perform? Get that estimate, right? And then execution, and then that's what I come up with a guesstimate time. Okay. So this is how you come up with it. So there is some logic behind it, right? So there is some confidence level that, hey, I can track it. If I'm missing any of those things, I'm spending a lot of times doing certain things, then I can talk with my project manager, with my users and say, this is the impact. Remember what we talked about as you go through it. Yeah, I'm going to do this testing, but I can do that only after the code is available, right? So I gave you a 13-week timeline with the assumption that the code will be available by this date. And if it is not that, what is the shifting? Right? So that's the conversation you do, because they're going to ask it, okay, how long it's going to shift it. So that's how you come up with a more or less kind of an estimation around how much effort it's going to do it. Right? You always start with some sort of it is, hey, what is the scope I have? How many test cases I need to do it, right? Because remember, it's not just testing it. You have to actually first write it, the step-by-step instructions. This is what I'm going to do it. And you're going to document it. In some cases, you have to run that 3-4 times. Sometimes even more than that, depending on the bug and how long it takes to fix it. Okay. Any questions of how you come up with that rough estimate? Okay. Yes.
Is that a team effort or just one person taking this estimate?
This is the total effort. It doesn't say how many people are involved, right?
Mhm.
You say it's, hey, I needed like 3 people to write it, but I may need it only like as 1 person to execute it. That's fine. Right? This is total effort I needed, and then you can factor in how many resources and what the timeline is. And it may be sometimes as simple as that, hey, for design phase, I need 3 people working simultaneously. For execution phase, I may need 4 people working it to execute it quickly. Right? But this is the total effort needed. That's what you're going to charge them. So think about when a contractor comes in, he doesn't tell you how many people he's going to bring you. All he just says, this is how much it's gonna cost me. And then he decides how many people he needs to bring in when. Right? Because all he cares is, can I get the work done under this cost? And all you care is, can I get this work done with this quality and this time frame? Right? You don't care whether they bring it 2 people to do a framing or they bring just 1 person to do the framing. Right? Any questions on this before we shift into different types of testing?
So after this is done, priority and severity can define, can be.
This is a piece of the test plan effort, right? You're giving them an estimate. This is how much time I think I'm gonna need it in order to do the test. Right? The priority and severity is you're just defining it, what levels we will use it. Then actual execution time, right? When you find the defect, that's when you say, okay, remember the rules that we defined to categorize something as critical? Does this defect meets that rule? Yes, then it's critical. No, where does it fall based on those rules? That's what you do at that point. Right? And again, it's a lot of times you may define something as a high priority. The project team says, no, based on this rules, it's not a high, it's a medium. That's okay.
So it's tester's job to come up with this.
Quality assurance persons, right? So if you are alone in the whole project, you will come up with this. If you're part of a group that is working on that project, where is leading it is going to combine everybody's input to come up with a singular version, right? But they say, hey, you're responsible to test the managed dealer functionality. So you look into that managed dealer and says, in order to test that managed dealer functionality, what effort you need? And then they will add it, and then they will combine it, everybody's effort to tell it one single number. Okay. But it's always whenever you go into the real world and their manager says, okay, you need to test this functionality. How long it's going to take it? They're going to ask you that question, how long it's going to take you to do that. And this is the framework that you use it to come up. Okay, let me think through it. Let me read it. Let me understand the requirements. Figure it out how many test cases you think you need to build it. And then you come up and says, okay, here's how much it's going to take it. Got a question online, Rohini?
So how does it fit into agile methodology? Like if we are following agile, it goes
So-
patience, right? So
even if you're following agile, right? It's a little bit different in the sense that you have a dedicated team and you're part of that team. But what it's going to look like it is, hey, you are going to work on this 3 features in this particular sprint. So they're going to say, it's okay, how much time do you think you will need it to build it? And can you get it done in 2 weeks? If you can get it done, what you can get it done? So that you raise the question and then decide that, hey, we can deliver this feature in this 2 weeks. We can do only this. The next feature needs to go into the next cycle. So that's how the conversation usually happens.
So we don't see codes at all. We'll be working in the front end, right? Like how the end user will see the front end. Like we'll be working with that end or like.
Most of you will be doing that, and we'll hold on to that as we go through it a little bit more, right? When you say you don't see the code, you're going to probably do a little bit more insight in the white box testing than the user does it, because you need to know how the different component fits it, so that you can test for those interconnection points and validate all of them working as expected. Okay. So, okay. Any other questions? So let's then jump into it. Now that you understood the test plan, let's talk about some of the terminology. Let's talk about different types of testing. Okay, so as you go through it, you're going to hear a lot of this terms, and then we will talk through it, right? So the whole purpose for this particular segment is to talk through it essentially, what is, when somebody says and throws a term, hey, I'm doing this type of testing, what does it mean? Who should be doing it and where in the life cycle it happens? Okay. So let's start with simplistic view. And there are multiple, depending on what terms you use it, there are different views. There is no, hey, it's one or the other only, always, right? So one view of testing is what is known as the static versus dynamic testing. Okay. So static testing is essentially type of testing that you do it without ever need to execute anything. Okay. So one type of static testing you already did is when I give you a requirements document and says, can you run it through 3C and T criteria? All you did it is type of static testing, right? You looked at it and says, is it possible or not? Yes or no, simple answer, right? Does it meet that criteria or not? Okay. So whenever you do those kind of reviews or do any kind of inspections, those are static testing. You're not writing or executing any code. You're just validating certain things. One of the other one, like this is type of testing that software guys does it, is known as compiler testing. Right. So remember I say this, you write the software into a much more human readable language. If you're talking English, right, there are some rules, there are some grammars that you have to follow about that language. If you're writing into a Spanish, there are certain rules that you need to follow. Right. Same thing when you're writing a software code, there are certain rules that you need to follow. And the tool that checks it, did you follow the rules or not, is a compiler. So you're not executing any code. All you're just saying, here is the piece of code that I wrote it. Does it follow the rules for this particular language or not? That's all it is. It doesn't say whether it's correct, wrong, right, or not. All it just says, did it follow the rules or not? That's compiler. That's type of implicit or static testing. Okay, when do you do this thing? Throughout the life cycle, you're going to see it. We just started with the requirements review, right? Every time you do a code review, so every time a developer writes a code, sits down with their peer and says, I'm trying to implement this function feature. And here's the code I wrote it. Can you check it to see if it's going to do it? Did I miss anything? Do I need to add any criteria? That's nothing but a static testing. Okay. And its primary purpose to verify, is it supposed to do what I'm telling you that it's going to do? Can you verify this for me? Can you verify it's going to meet the 3C and T test? If not, can we update it so that it's verified? Okay. The other side of it is a dynamic testing. It's essentially, it's a testing that I cannot do without executing any piece of software. Right. So it's not static in the nature. It's going to execute it and it's going to change the state. It's going to change the behavior. And then I'm doing testing for that. So for example, we talked about functional testing, right? So if I'm doing a calculator, all right, and if I'm adding a 2 + 2, that's dynamic, right? I'm entering the input. I could enter different input. It's a dynamic, it's changing input. So whenever you do those kind of testing, that's called a dynamic testing. It's a functional testing. And the purpose of functional testing or dynamic testing is to validate. So the first one, static, is verifying. Is it going to do what I'm telling you it's going to do? Can you verify that? This one is validated. That means the software is already built. I'm validating it. Is software doing what it's supposed to do? Okay. Good with that? Okay. So that's one view. The second view of testing, the terms that you will hear, it is a black box versus a white box testing. Okay. The black box testing is the testing that you do without knowing how the internals of software works or how the software is built. All I care is I'm going to give this input. I'm expecting this output. Is it giving me that or not? I don't know how it calculates that output. I don't care. Fine. That's a black box testing. The purpose of it, I don't have to know the internal software. I'm testing what the software is supposed to do, not how. Right? It's what is it supposed to do. Okay. A lot of times you will hear it like specification based system. Most of the manual testing that you're going to do it, I think majority of them will fall under black box testing because you don't know how the code is written. Right. So if I tell you, hey, let's test Rflow, right? Can you say it is the manage dealer, the create dealer functionality works? Right. You're going to go to the screen, you're going to try to add it and try to create it. And going to say whether it works or not. Right. You don't know actually underneath that how it is implemented. Is there a database? It's a query going? You don't know any of those. Right. That's a black box testing. Versus white box testing is essentially, I know exactly how the software is written. And I'm going to write my test to make sure I test everything properly. That's white box testing. Okay. The intention is how the software is performing, not instead of what the software is doing. Okay. So one example there, right, is if I know exactly how the implementation is done. So let's take a simple example, right? So all of us do some sort of loan somewhere in the life, right? Everything is driven by your credit score, right? So if we just say, hey, my business functionality is going to tell me that if a person's credit score is 800 and above, you charge them one interest rate. If it is between 600 and 800, charge another interest rate. And if it is between 600 and 400, charge one. And if it's below 400, we don't give them a loan, right? And somebody writes a software code for that. And you're reviewing that code or performing a testing that I know if it gives between this and this, it should come this way, right? Because I know how they've written the code itself, including if then else. If it is above 800, do this, else if less than 600, do this, if else less than. And when I write the test to say, did it traverse all those if conditions properly? That's a white box system. Right? I need to know exactly how the code is written before actually testing it. Good so far with those two terminology? Now let's go to the V that we talked about, right? And we're going to go from a bottom to top, right? So remember at the bottom, if I have functional specification and technical specification, where I'm going to go? Unit testing, right? So unit testing, it's typically a white box type of testing. It's a testing done to verify a specific section of the code, right? So that means I know how the code is written and I'm testing certain pieces of it. Okay. It's also sometimes people will refer as, hey, this is a component or a program level testing. It's done way early in the development lifecycle. While the developers are writing the code, they will also write this unit test. Right? Because as they're writing the code and changing the code, they need to make sure they're testing all the paths. So this is type of white box testing, and typically it's done by developer, not by you. It's done by developer because they know exactly how the code is written. And it's done in an early life cycle of the development phase. Then the next level comes in is integration test. I have a small section of code working fine. I'm trying to bring two pieces of program together to see if it functionally works as a one piece of code. Okay, that's called an integration. So that talks about if I'm a retailer, right? Like it's an Amazon, right? And I want to make sure somebody purchased the book and they're now going through the checkout process, right? The checkout process is going to say, hey, I'm going to give you credit card information. And now I need to go and validate, is the credit card work perfectly or not, right? So I may still be doing it. It says, okay, in order to validate whether this credit card is working or not. I need certain pieces of information, right? I need credit card number. I need expiry date. I need what they call it CVV code. I need the name and address of the person and where the credit card is registered, right? And then I need an amount. What is the amount that you're going to charge it, right? I need to make sure when I send that pieces of information to the other code, it is working fine, right? So it is the component that I've written it and it's sending it and getting back that responses that working together as expected. That's kind of integration test. I'm integrating two components, right? The component which essentially takes the shopping cart and the component which then goes out, sends that information. Can I extract that information from shopping cart, hand over to them, whatever they're typing it, get that, build it, a query that then can go to the payment system, right? So that's an integration. That is also done typically by developer, and it's still done in early stages of the development cycle. Right, so you write the unit code first. Everything works at the unit testing. Then I take two pieces together and integrate them. That's when this thing comes in. Still a white box testing. Still the developer does it. Okay. I'm gonna skip this for a moment and we'll come back later. So the next one is system testing. Okay. So now I have each of my components working fine. I'm going to bring it together to create a system level functionality. Okay, that's when it comes in. The whole goal is the system meeting its functionality. Okay, so the key word here is functionality in the system. So now I'm bringing pieces together. So now I'm at a level where I can start tying directly to the requirements. Right, I can start tying it to my acceptance criteria. So that's when you come into play as a quality assurance person or test team. You're going to start doing that. The developer is going to give you pieces of software that is working collectively. You're going to start testing it. Does it work as a cohesive system? That's where this thing comes in. Okay. And it's done typically in the testing phase of the software development lifecycle. So you're done with the implementation, you are now in the execution phase. That's when you start doing it. Other thing is also, this is where you start transitioning from a white box to a black box testing. Okay. Everything so far in the unit testing and component testing or integration testing, developer knew exactly how everything's implemented. As they go through it, you're trying to bring two pieces of the system together. You don't care how they're implemented. All you care is collectively, do they perform as a one system? Do they perform functionality needed? Okay. Then another component is a regression testing. Okay. So now think of a cycle, right? So you are in the system testing, you're performing certain tests, you identify something is not working. You created a bug, right? You gave it to developer and says, hey, you know what? This particular functionality feature or capability is not working as expected. They go and says, oh, okay, I know what to do it. Let me fix it. They fix it, give you, here is the new version of it. When they give you a new version, right, you need to make sure, A, did they fix the problem that was originally there? But you also need to look at it from, while fixing that, did they break anything else or not? That means you need to go and test it. Remember all this thing was working before? Let me make sure it still works now. Right? That's a regression testing. It's essentially testing piece of software that was already working before, making sure it's in a new build. Whenever they give you a new code, it's still working the same way that it was working before. And typically you do it during testing phase. Every time a developer gives you, here's the new version or new copy of the software for you to test it with the bugs fixed, you need to make sure everything else was working before. Okay, that's a regression testing. That's typically performed by the testing itself. Okay, now let's go back to the two that I had skipped, right? So sanity testing and a smoke testing. Okay, so whenever developer gives you a new piece of code, right? Typically what you do it is you first run it through sanity testing and says, is it even ready to be tested? Right? Whatever they gave you, is it worthwhile spending the effort to do any testing? Okay. In order to do that, you do certain small quick testing. Like for example, if they give you a new piece of software and then you try to bring it up the homepage, let's say they give you a web application and you try to, it says, hey, that you can access the application at this URL. You put in that URL, make sure does the application come up or even to start the testing. That's a sanity testing. Right. Whenever they give you a code, you need to make sure, can I even bring it to start my testing? That testing is called sanity testing, and it's typically performed by testing, and you do it every time they give you a new piece of code or new version or a copy of the code. The first thing you do is it ready to do it? Because if your application doesn't even come up, can you do it? Proceed with your testing? You cannot, right? You have to go back and say, you know what, basic pieces doesn't work. Get it working so that I can start testing. Okay. The second closely tied with that is something called as a smoke testing. Okay. So just because the homepage came up, that doesn't mean everything is working, right? Because there are a whole bunch of, remember when you talk multi-tier, you have a presentation tier, you have an application tier, you have a data tier. How do you know that all of those components are up and working? That means you need to do certain a little bit more testing. It may not be formal testing, it's kind of like smoke testing. Can I get it through end to end? Right? So is my database is working? Is there a basic problem that prevents software from working? So if database is down and you have only like it's a front end and application tier up, can you proceed with it? You can't, right? You need still that data tier to be up so that you can like it's validate, even if my as simple as my login ID and a password valid or not. Right? It requires you to go to front end, performs the business logic to determine who you are, goes to database and says, is this a valid password for this person? Right? So whenever you do that kind of testing, which is a little bit more than sanity testing to make sure, is every component of the system up and running as expected? Can I proceed with that? Is the build working as expected? That's called smoke testing. It's done by testing team, also in the test phase. Okay. Whenever there are two places where you do it, whenever they give you new code, or a lot of times when they said, you know what, I need to reboot the system. When they reboot it and bring the system back up, remember, they didn't give the code, they just restarted everything. At that point, is everything working as expected? So that you can proceed with the testing. That's a smoke testing. Okay. Any questions on any of this before we proceed to the next one?
So sanity testing is not related to any of the functions of the application. So it's
Just saying, is it good enough for me to get started? Right? So it's not an elaborate testing. Just that, can I bring homepage? Can I log in? That's a sanity and smoke testing. That's why you see a lot of times very interchangeable activity that says, oh, I need to do a sanity and smoke testing. Right? Or they said sanity testing, and sometimes they say you restarted it. Can we do a smoke testing to make sure everything is up and working? Okay.
Which one comes first?
So always your sanity testing comes first. You need to make sure, can I even begin with the testing? And the smoke testing is, does all the components work? So we talked about through the system testing, right? So unit testing, integration, system testing. We talked regression testing. The next aspect is the functional testing. Right. So this is where you start looking broader within the system and not only just says, hey, all the component parts and pieces of system working, but they're working as a collectively from business functionality point of view. Right. So you start doing the functional testing. Right. So it's not about managing dealer, but can I sign up a new dealer? That is the testing I'm doing in the system. That's a functional testing, right? It tries to verify a specific function of the software. For example, right? The system testing could involve it is, hey, whenever a dealer approves or rejects it, does the email sends out? That's a system level testing. Functional testing is, can a dealer approve or reject credit application? Right? And when they do it, what all the other things should be working? That's a functional testing. Okay, so it answers the question, is a specific function working as expected or not? Is the user capable to do the task for this particular function as part of the system? Okay, it's done by testing team, done in the testing phase, right? It's part of it, follows right closely after the system testing. Okay, so when your functional testing is working, right? So now you established, as long as your unit code is working, integration working, system is working, and functional is working, you're saying that this capability and feature that a user wants it is working as expected, right? So the basic functionality of the system is up and working. So the next question is going to come in is, okay, great, it works for one user. Will it work when 50 users are working together? Will it give the same response time? Right. So when you try to answer that question, that's a load in performance testing. Right. Simple question that you're trying to identify is, does the system work as expected under the capacity in which it is designed or expected to function? Now, this one requires a little bit more involved than you just trying to do it one user, right? So let's take an example that I was talking about Black Friday, right? 1 million people comes in. How do I load and performance test before Black Friday comes in? Is that, can my system handle that 1 million concurrent transactions? And what the performance going to do it, right? So it's going to require you some more automation, some more additional tool than you simply doing manual testing. Can I check out an item? Right? As a one user, I can do that just fine. What happens when there are 1 million users trying to do the same thing? Is the system performing the same way? Is the response coming in, and can I work it so that all 1 million people get what they order and not what somebody else ordered, right? That level of things. So that is essentially aspects of load and performance. It's trying to verify that can system work under the load as expected and perform as expected. Okay, it demonstrates the system stability and how it can work against the capacity that is proficient. Okay, it is done by testing team, typically in a later stage, right? So think of this way. If I cannot get an individual check-in working, does it make sense for me to do it? Can 1,000 people check in at the same time? No, right? Because if one person can get it right, forget about why even bother about testing whether 1,000 people can do it or not. So this one typically comes after all of your functional testing is working. That's when you do load and performance. And it's performed by testing. A lot of times it's dedicated teams which are performing this performance testing. Okay. And not every time every system does the load and performance testing when they go through the development. Okay. Think about it, right? If it's a small system with only 10 or 15 users expected to use at a given time, do you need an elaborate load and performance testing? Probably not. But if you're like, it's doing like Amazon, where it's scaled to thousands or millions of users, right? You're going to do the performance testing to make sure that it works as expected, right? Tomorrow it's going to be NFL, right? There's a whole bunch of people will watch stream online, right? So if I'm building a system to provide that streaming capacity and capability, it better work with the millions of users. But if it's going to keep buffering, how many people wants to watch it? Right? That's an example of load and performance testing. So a lot of times it's requires additional skill than the manual testing. And a lot of company, depending on how big the company is, they have a dedicated load and performance teams. And they also have a dedicated environment to do the load and performance. But occasionally they said, hey, we're going to do load and performance testing every Thursday night from 10 o'clock to like 3 a.m. in the morning. So nobody else uses the environment during that time. It's going to be used only for load and performance. So that way you can either segregate it or you can create a dedicated environment to do it. Okay. Any questions around so far before I hit in the stress testing?
So during unit testing, the developer is writing the functionality testing too. Are we using the
No,
same?
developer is not writing functionality testing. They're writing all the code path. What do I need it in order to execute that code path? That's what the developers are writing.
So we cannot use that as when we do that.
No, it's each is different level testing. Right? Because the code testing comes in, there's a lot of, as you go through it, there's a multi-threading, this whole 9 yard comes in, the jargons the developers use. Right? So think about it. Anything that they do it is with the white box knowledge. The load and performance is not with the white box knowledge. It is with the black box knowledge. If one user can do this, can 1,000 users do it at the same performance level at the same time? That's what the load and performance testing is. Yes, Rohini.
So the performance testing is not done in the QA environment. It has a separate environment then?
It could be done in the same environment, but it's done during a dedicated time, or it could be a separate environment, depending on the size.
Okay.
This is an investment, right? We're trying to make it similar sizes of production. Not every company can afford it. So
So would it be an automated testing in this case?
it will require some automation. You can't have 1,000 people sitting at the desk trying to run at the same time. It's not effective. So there is some automation is required. Does it go fully automated? Depends on a case by case basis. Okay. But obviously, like, 'cause you can't fire off, like, you can't hire a million testers to run at the same time, right? You have to do some sort of computer simulation to do it. Right? That means a record and plate, some type of thing. Any other questions?
So is static testing, white box testing?
Static testing is always white box testing. I know how things are done in order for me to review it, right? I'm not executing anything. But again, I want to be careful. Not every static testing is a white box testing, from the sense that when I'm doing a requirement review, there's no code written, there's no white box. It's just that what are the capabilities that I'm doing, and can I test those capabilities?
Static testing is basically like how we review the document.
But it's a review. It's without executing any piece of code. Yeah. The next testing is a stress testing. Okay. So stress testing is a little bit different than load and performance testing. What stress testing talks about it is how much load I can put in the system before it breaks. Okay. So as I mentioned, like last time, right, with Enigma, I'm kind of like, it's a lot more science and technology, and space is always like, it's one of my hobbies and interests. So I don't know, have any one of you watched a movie called Apollo 13? Right? It is the movie about NASA sending humans to moon. This is back in 1970s. Okay, this is when the mission to the moon had started, right? So Apollo 13, it was like, it's their fourth mission going all the way to the moon. Like, on the way to the moon, there was a blast. Right? That means half of the ship is crippled, right? It's not like you're on Earth that you can just step out of your car, open the hood and fix it. But you're in space, you don't have any equipment, you can't step it out, right? So if you watch that movie, it's about like, it's how they get the men, because the craft was still on the way to the moon when the blast happened, right? So the question is, do we turn around and bring them back? The goal was not to just bring them back, right? To bring them back alive. And how quickly they do it, because they don't know whether the oxygen will last it. The time that they can bring it back, because the oxygen tank was blown. Right. So it's about the movie of how they essentially look at what is the capacity of everything that is left. How much stress that they can put in before it can break it. Because the goal is to stretch as much as before it actually breaks it. So that they can bring the people back into the earth. So they ended up deciding it is that they're going to continue the journey to the moon and use moon's gravitational power to push back them faster to come back to Earth. Okay, but where the aspect is that they had a simulator on the ground, and one of the astronauts actually sits in the simulator and then replicates the condition that they had it up in this there and try to replicate and say it. Can I actually push it to the bound? Because I had to shut down a whole bunch of systems. And the question is, can I restart the system? Right? Because if the system doesn't restart, they can't land it. So it's an example of how they did the stress testing before things break, and it says, oh, at this point, it's going to break it. So we're not going to push the system to that point. Right? So a lot of another system, like it's at the when 9/11 happened, right? So when back in 2001, I was part of the telecom firm when that thing actually happened. There was failure because the amount of the people who actually try to get through 911 in the New York area, right, it exceeded any design, any plan that I was ever put in place. So the system failed. People could not get their call through 911, right? So when they try to do that, they always do it like it's for critical systems. They try to do it stress testing. It says at what point it's going to fail it. So we know that we can push system only to that point. Anything more than that will not work, right? So even when they design new planes, right, they identify till what speed we can run it before the frame starts disintegrating, right? What is the stress testing? So whenever you do that thing in the system to test it, they says at what point it's going to break it, right? So they keep adding a load to that till you find it at what point system breaks it. That's called a stress testing. Okay. It's talks about it's what is the system reliability under unexpected or rare workflow, right? So we know in the load and performance testing that, hey, system was designed for this load, can it handle this load or not? This one goes beyond what system is designed for. Can I put an additional load? And at what point it will start failing? Okay. It's done during testing phase, and it's done by a testing. However, this is an optional. Very few systems will go through this testing because it's a destructive testing. You're actually breaking and failing the system at this point. You're not just like it's kind of doing it, you're actually determining the breakpoints. Okay. So this thing is done only based on a business request. And a lot of times for the load performance in a stress test, there is a dedicated team which does it because it requires a lot of automation and incremental addition to the load so that you can actually monitor the behavior of the system to figure it out the stress point. Okay. Any questions so far? All right. So at this point, right, when you think about whether you do an optional load and performance and a stress testing or not, right, you have a system that is working. You tested it, make sure everything is working as per the requirement specified. So now you turn it and says, okay, we have done our testing, it's ready. Users, now it's your turn to say, it's A, is it fit for your purpose? 2, will you accept it or not? Right? In order to do that, they perform the testing to check it. Does the system meet the user's expectation as specified in the requirements document? And it's typically done in the acceptance phase of the software. Remember, we talked about the execution in the circle, right? That I'm going to review and audit and make sure it's ready. And then next step is acceptance. That's when this testing happens. It's typically done by end users or their representative. But a lot of times they delegate that responsibility to the quality assurance team. It says, here are the different scenarios I would like it to be tested. Can you test it on our behalf? That's how typically a lot of times happen. Some cases, we have actual users come in and says, okay, I'm gonna sit down and do the testing. Okay. That's what this thing is happens. Okay, when the user acceptance testing is done, that means it's if it's successfully completed and user says, I'm satisfied, that's when you say it's now system ready to go live or it's ready to be pushed out. Okay. Any questions on UAT? So that completes the cycle of the user interactions. Okay, now there are additional terms that you're going to hear as you go through it. One of the term is a backend testing. Okay, so a lot of times there are functionality that is identified which doesn't have a specific front end for you to test through it. Okay, let me give an example. All of you read through the requirements document, and one of the requirement was auditability. Right? It says every transaction that you do needs to be captured in the system so that we know who made changes to credit application when they made the changes. Right? When you look at it from the front end, all you're going to see it is creating credit applications. And whenever you do it, you need to make sure any changes somebody made it, did it get captured in the audit log or not? So it's going to be directly in the database. So sometimes you as a quality assurance person have to actually put some queries or testing on the database to say, hey, I performed this. Did it make a difference in the database? Is the audit log was generated? If so, let me query it and look at it. When you do that kind of testing, that's called a backend testing. It's something that you're doing it behind the scenes to validate this, the functionality working as expected, because I have no way to validate that through the user interface. Okay. And it's, again, you as a test team do it in the test cycle. Everybody clear? What the difference between the backend testing versus other testing?
So if you are developing a common software like over the shelf we were talking about last week, so it like we'll be testing like different OS and what operating system it will work, like kind of stuff. What category that testing?
That's we're going to talk in a moment, but that's not a backend testing. That's still a user front-end testing.
Yes.
Right. So when you talk about the application, right? Specifically web application, there are other things comes in to play, right? So traditionally before the web application, right, all of the environment was under your control, right? You as a company build the software, you tell it, here is how it's going to work it. But when you go to the web world, there are a lot of things which you need to think about it, which may not be in your control that you need to validate and test it. Okay. So the first thing we talked about is the system fit for purpose, right? That means as a user, can I use it? So in the web world, there's something called a usability testing because you don't have control, right? Or what speed or the throughput or bandwidth they will be connecting it. But can the user use it, right? One of the other example that usability testing comes in, a lot of times people build this software with the right mouse click, right? Not necessarily everybody has a right mouse click, right? So if you use the phone, you have a right mouse click, you don't, right? If you're accessing the same thing from your desktop, you may have a right mouse click depending on the operating system you're using it. But otherwise you may not have it, right? So are you building some of the application and feature and capability with that? At that point, is it still usable for the people who are trying to use it from phone? Right? That kind of testing that you do is that, hey, what is the targeted intended environment and can people use it in that? Right? Another aspect is the response time. Is it acceptable? What happens if I lose the connectivity? Is that usability? So you have to do that for a web application in addition to what you do normally, your traditional application. Obviously, functional testing, irrespective of whether you're doing a web or regular application, you have to do it, right? Because if there's not, if the function doesn't work, it doesn't matter if everything else works or not. Nobody is going to use it. Other aspects that you're going to think about it when you do the web testing is called compatibility testing. Okay, so this is where you talked about operating system comes in play, right? When I'm deploying application on the web, I do not have a control of what version of the browser people use it, what operating system they do use it, right? Think about it, there are tons of versions of the Microsoft Internet Explorer, then there is Microsoft Edge, then there is a Safari, there is a Chrome, there is a Firefox, right? There's a tons of different browsers. And you don't know what your user is going to use it for that application, right? So typically what happens is you identify as part of the requirements. You identify as a requirement, what are the targeted operating systems and the version of the web browsers that you're going to use, right? So you will see it a lot of times when you're trying to access certain application, it will pop up and says, hey, it works only on Google Chrome or Firefox or that, right? Because they designed the system says, okay, we're going to focus only, it's going to work in this. Anything outside that, we're not going to support it. Or in some cases, they said, we're going to support this 4 browsers and these are the versions. So you need to test it, make sure as a quality assurance and tester person, can you log into all these different browsers and test the feature and functionality to say it still works as expected? That's compatibility testing. Okay. The next thing we talked about, the database testing, backend testing, right? Validating anything that created is that got created the way that is expected in the database. The next one is a security testing. Okay. So as you go through the web application, so if I have something within the bounds of the company's firewall, I know that chances that people tap into it is going to be less. But if I'm doing over internet, and let's say if I'm sending my social security or sending any of the financial information, right? Typically, you don't want it to be open wire, right? So anybody on the internet can tap in and can read through it, right? So you're always going to have some additional security requirements. It says that every transaction that goes through it, make sure it's encrypted, right? So a lot of times they say it's, even in the design documents, right? You said all of the financial data has to be encrypted in SSL format, right? Which is nothing but a secure socket layer. You can read it through it on internet. But what it does, it is every time a traffic or information leaves from your computer to go to that server, everything needs to be encrypted and sends it so that even if somebody taps in, they can't make any sense out of it. Okay, that's a security testing. You need to make sure, hey, if I'm doing it, right? A lot of times you see it in the browser, right? Depending on whatever browser you're using it, the lock button turns on, right? Which says that, hey, this data that I'm sending is now secure data. The site is a secure site. It's not that open encrypted that anybody can tap into and listen to it. Right. So you have to do that kind of testing for the web application. Make sure the transactions are sent over the secure connection and not over the open connection. That's a security app testing, right? You also want to make sure that can people hack into it. Right. So if I kind of try to do a site administrator capability, but if I'm logging with the credential of a dealer, I should not be able to do all the functions that, right? Those kind of things gets part of the security testing. And the last aspect is performance testing, right? Because as it goes over the internet, is the system still performing it over the common denominator of the bandwidth? That's the kind of testing that you need to do it, right? A lot of times you will just say it is, hey, depending on the connection you're doing it, if you're like specifically using some of the streaming services, right, like Netflix, YouTube or anything, you're doing it over your phone, it'll determine what the bandwidth is. And depending on the bandwidth, it will like adjust it to give you a low quality video feed over the high quality video feed. Right. That's nothing but performance aspects of the application. Can I change and fine tune things based on the connectivity that you are having? A lot of times you will see it, if it's a very image sensitive website, they will bring it up the website, but then you will still have images which says, hey, it's trying to fetch the image, right? So it'll still display the web page, not in entirety with all the pictures, but you will have all the basic content. And then over like its next 2 or 3 seconds, everything will get refreshed with the right high level image. That's another example of performance testing that you need to do. Okay. Any questions? Are you guys clear in terms of the different types of testing and the terminology that you use? Okay. So we'll write a lot of those testings on that. So one of the other aspects that when you do the testing is how you're going to do the management around the issues or defects that you identify. Right, that's an integral part of you testing it and communicating back and forth with the developer to say, hey, I found this error, needs to fix it. When they fix it, what all level of regression testing we need to do it. So that entire process, which kind of deals with the defect, is known as a defect management process. Okay, so let's take a quick look at that defect management process. And then we'll like it's kind of pause it for the day and then start talking, what are we going to do tomorrow? Okay. So the defect management, the whole goal is to understand what is the life cycle of the defect is. Remember, we have software development life cycle, we have testing cycles, but the defect is its life cycle, right? So what is the life cycle? We do that. So let's talk through the defect first. Okay. What exactly is the defect? Right. So there are a few things that you need to understand. One is defect is an error. And when you say error, it's essentially any deviation from the expected behavior is defect. Right. So let's say if it's, hey, the screen should display the first 3 users, or let's say they say it. Okay, if that's what your requirement says. And then when things comes in, it displays 5. Right. A lot of people don't characterize that as an error, but it is still defect because it is different than what is the expected behavior. Expected behavior was to show only 3 users. The actual behavior is you're showing 5 users. So that's a deviation from an expected result. Right? So that is a bug, right? So it is behaving in an unintended way. Right? It doesn't matter whether it's right or wrong, right? It is deviation from what was expected. Okay. Again, it's a variance. However, with the key difference, if your requirements document was ambiguous, okay, and because of that, software behaves differently. That's not a defect, that's a requirement problem. Right? So you need to make sure that that is the distinguishing you do it. If something is kind of identified, hey, I can't predict it what it is, but the requirement didn't tell it what it should be either. That's not a defect. Okay, that's a problem in the requirements. Okay. So let's talk a defect life cycle. What happens? Okay. So typically, whoever is performing whatever type of testing. Okay. One perfect example, right? We looked at it, the 2 different documents, right? System requirements document and system design document, right? And some of you pointed out, hey, requirements document says one thing. Design document says other thing. What it's supposed to do, right? To me, that's the start of a defect, right? You review it and you identify there is a mismatch. Right. What you do is you open a question. It says, hey, this needs to be fixed. They both needs to be consistent, can be inconsistent. Right? You found it and you assigned it. And it says, hey, Mr. Business Analyst, you need to go talk to the developer, or sorry, talk to the end users and figure out what should be the right one. Right? You will review it. And is that 2 different things, or actually it's a complementary thing, right? So project management says, yeah, it is meant for this versus this. So it is 2 different things. You're thinking it is one thing. That's why you're doing. So they could reject it and says, that's not an issue. Or they say it's, you know what, you're right, this and this doesn't match. Let me go ask that question to the business unit, says, what do you want it in this scenario? Right, and they will say, I want this and this. So you go back and you fix the document. And you give it back and says, okay, now this updated document is ready for review. Right, you get that. You as a quality assurance person look at that and says, oh, now it's clear that it meant to be this only, right? So you can close it or verify. But if they give up something and says, no, it still needs some more additional clarification. It's not very clear whether it's this or that, whether it should respond in 2 seconds or it responds in 5 seconds. So I need more clarification. So you reopen, it goes back. So you keep going that process till you close or fix that issue. Right? That's an example of a static defect. You're going through the cycle. Same thing, it's when you're executing and you find a bug in the software. Right? You open it, you assign it to the development team. They look at it and says, is that truly a bug or no, it's you're entering the wrong data. That's why you're getting, you need to enter only this data. Go add it, fix it. Right? They flag it that it's ready to be resolved. So you do the testing and regression testing. And if it's working as expected, you close it. If it is not, you still get the error, you reopen it and then address it. Okay. So that's the life cycle for a defect. Okay. So defect management is essentially you put a process around that life cycle to manage all of them. Your goal is essentially always to prevent the defect. Right? You want to make sure you have a process in place that essentially eliminates the probability that defect is introduced. For example, we talked about reviewing a requirement document before you actually build it. Right? Think about it. If before they build it, if you identify that ambiguity and resolve it in the requirements itself, you're not going to have 2 different implementation, right? That introduces a defect that needs to be fixed. So your goal is always to prevent the defect. Can you prevent every time? Probably not. There's always going to be something which is going to creep it into it. But whenever that happens, your goal is always to identify as early as possible. Right? So the early detection is the key goal for the defect prevention process. And in some scenarios, you won't be able to detect it that early. And then you identify that late stage. But whenever you identify that defect, the goal is how you're going to minimize the impact of it. Okay. So let me give an example. As I said, I enjoy watching space stuff. So back in November, NASA is trying to send its new version of Orion spacecraft back to the moon. Right. So they had a test launch that they had planned it in November to do that. Right. Their goal was always you don't create an issue when you're launching, right? Because it's money, people, life. There's a whole bunch of things that's involved. Okay. So your goal is always to make sure the launch goes as flawless as possible. Right. That's the goal. Is it always possible? Probably not, right? So your goal is when that defect creeps in, you identify before it actually occurs, right? So in that example, right, they had to postpone the launch 3 or 4 times because as they were doing it, they say this valve is faulty or this thing is not operating properly when we did the test on the shuttle's engine and all those things. So you identify all those things and you put it in a plan in place that enables you to identify. That's an early detection, right? And once you identify, hey, there is a faulty valve. Well, how do you minimize the impact? You don't launch the rocket with that faulty engine or faulty valve, right? You essentially say, I'm going to postpone the launch. You're going to fix it. Is that a cost? Yes. Because now somebody has to go cost it. Specifically, if they've done it after fueling the proponents or liquid oxygen and the hydrogen that they fuel it in those rockets, right? You're gonna waste all of them because you have to dump all of them. So there's gonna be a cost associated with it. But that cost is a lot less than if you would have launched it and destroyed the rocket. Right? So the goal is to minimize the impact. Same thing in the software world, right? You eliminate as many as possibility to introduce that. But once it's introduced, you want to identify that early. That means if you can find it in design phase, that is better than finding it something that you put into production. Right? But as soon as you identify the defect, what can you do to minimize it? That's another one. Okay. It's always cheaper to prevent the defect instead of creating a defect and detecting it and fixing it, right? So prevention is always the priority that you need to think about it. Here is the example of how much typically a defect costs. Okay, so this was done by collecting a lot of data in the early 90s and 2000 across a whole bunch of systems. Okay. So if there is a defect and you identify in the requirement phase, right? The cost to fix it is very minimal. What is the cost? Usually going, talking to the user, fixing whatever things was not matching it and doing it. If you let that go into the design phase, right? So the requirement, it was not caught that there was a mismatch. You go into design phase, the developers and architects are designing it. And they identified, hey, you know what? I don't have correctness in this one. This is missing some pieces. I need to know this additional information. Think about what is the cost at that time? Well, I need to go back to the users, whatever the requirement they get it, and make sure the requirement is validated and we come back into the design. Still not a big, right? It's maybe a couple of emails back and forth, some more time, maybe 1 or 2 meetings extra. Same thing goes to the code. I have designed, I've started implementing it. Now I find an issue that needs to be addressed I may have to rewrite some code, right? So the amount of the effort is read it is probably higher than what I recorded in the requirement. A lot of times it's only 4, not in just simple time, right? It's 4 or 5 folds, right? Because I have to rewrite all of the code. I have to redo the testing or unit testing, whatever I'm doing it. I need to go back to the users, get that particular requirement, make sure it's a design and architecturally it fits into the picture. So the cost is a little bit higher, but obviously it's not as high as if it have passed my coding and gone into testing. Now, because you have to add a regression testing on top of it whenever I fix it, right? So it's not just me fixing it and giving you have to do a whole bunch of testing to make sure nothing else is broken, right? So the amount of effort is required is even higher, right? It's probably double the size of what I needed in the code space. Great. But if I fail it to detect in the test, and now it goes into production environment, right? The cost escalates almost 100-fold. And remember, the cost is not only just getting into fixing the code in production, right? But it could have created some data issue. So you need to go back and fix those data. It could have impacted the customer, so there could be financial repercussions. It could also have a PR issue, right? Reputation risk now. Think about it, right? So during the COVID time, right? Everybody was accessing all of their credit information, everything from home. So the amount of the transaction going digitally escalated significantly during the COVID, right? And that's when I don't know how many of you keep a track, right? One of the credit bureau, Equifax, had identified, hey, there was a security breach. People could access each other's data and that. Right? And hackers could come in and get all of the customers' data, and they had about 300 million customers who were impacted. Right? It was a small mistake that they let it go through it, their security, so that how you can prevent it from people seeing each other's data and all those. What was the result? 300 million customers were impacted. The reputation was identified. And then they had to pay fine to the government because they violated the people privacy data. On top of that, to that 300 million users, they have to provide 1 year of free credit service, credit monitoring service, which was $150 per person. think about it, the escalation and amount that they had to favor. That's a production cost. If I find it, because I found the defect then. Right? So it's always when you look at this chart, right? I would rather fix my error here than trying to fix it here, right? So whatever your defect management process is, you want to make it much more effective so you can identify it as early as possible. And even at this stage, it's still costing you. What if if you can eliminate this altogether, then you can save a lot of money. That's why it's important for quality assurance to get engaged early in the life cycle and not at the testing phase. Because if you just come up only here, defect is already introduced, it's going to cost you tenfold to fix it than what you could have done it before. Okay? And these are the real data from multiple systems that they average it out, how much it's going to cost it. Okay. So what is your defect management process looks like? So typically, you put a process in place and says, this is how we're going to prevent the defect, right? We're going to do the reviews. We're going to do the code reviews. We're going to do a design review. We're going to do a requirements review and make sure all of those things is met. So that's my defect prevention process. I baseline that process and then every project needs to do that. Then it goes in and says, whenever I find a defect, right, I need to think about it. Hey, what defect I found? I need to make sure I understand what did I do to resolve it. I need to provide all of that information into the reporting. Then I need to click it on and says, okay, now that I have all this data, I know what my baseline was, but what I missed it, can I change the process to prevent it a little bit early, right? So you do the change management and feedback into the prevention process. Says, for next project, make sure you do this also in addition to that, so that you don't run into this issue. And throughout that, you're reporting it to see what data you're collecting it, how many defects are being discovered, what cost of resolution is, what activities you need to do to resolve it, right? Can you update it? What happened when you updated that process? Did it actually prevent that problem, or it's still allowed to happen? All of those data gets into the feedback loop. That's the overall defect management process. Okay. So how do you do that? Right. So there are multiple ways, right? The simplest crude way you can track it is manual, right? Put into some sort of a list or Excel and say, for this test case, I identified this defect. Right? That's a most simplest crude way. Or you can do it as a dedicated defect management software and says we're going to track it in there. Most of the modern lifecycle software essentially allows you to do the defect management as part of that entire software suite. So everything is integrated, right? You can go up to that much. Okay. So, but the whole purpose is to understand that the detailed records for every defect so that you can actually utilize that data to update your defect prevention and the defect management process. Okay. So when you get a defect, what is the kind of information typically you're tracking? Right. So typically you want it, every defect that you identify, you want some sort of a unique identifier, right? Whether it's system generated or you manually created, that's an ID. But that ID or number is not good enough, right? You want to understand actually what type of defect it is, right? Whether it's a requirement mismatch or is it a code defect, whatever that is, that you identify the defect type and the name. Then you identify what is the source from where you were able to identify that defect. Was it a given test case, or is it a requirements review session or a code review? That's where you can identify. The next two we talked about, right? The severity and priority. Is it cosmetic to the critical? Is it low to high? Right. You use those. And you also identify, track a status. Is it a new defect? Is it a reopened? Is it ready to be verified? Right. As you go through it, that life cycle that we talked about, right? Okay. It's going through this life cycle, right? So it's going to open, assign, fix, need to be verified. reopen, close. All of those are nothing but life cycle stage, right? So you provide where I am in that status so that I can see the trajectory of that. Then I also identify some additional details around it, right? What is the date and time that it's found? So I can start tracking the age of defect, how long it takes it to fix it, what is the impact, how many people needs to be involved in order to fix it. Also, you identify actually the step-by-step instruction of how can I reproduce it, or what was I doing it that essentially led me to identify the discovery of this defect, right? So you can say, hey, I was executing this test step, I did this, and in the step 4, this is when I noticed this, right? The purpose of that is when you do that along with the screens, print or log or anything that you can provide it, is a developer can actually take it and says, can I reproduce it? Right. The more effectively you can reproduce it, the easier it is to identify the source of the problem and says, what do I need to do to fix it so that it gets eliminated, right? So all of that information is crucial, right? Some of the things you can track it is, hey, which component or function? Remember we said that I want to track the product metrics, which components are showing how many defects. So all of those things helps me into that, including stage of origination. Did I find it in the code? Did I find it in the design? Or did it actually went into the production and I found it? Then you will also like it. This is exactly same that we talked about, right? High, medium, low. High is it's something that I need to address right now. Medium is I can live with it. Low is if you have a bandwidth, just go ahead and fix it. Right. Severity, right? Some example, right? How critical it is. Right? And a lot of what is the impact? Can I perform a business function without that? Yes, no. Can I still proceed it? Is it going to lead to data corruption? Is it going to lead it to the customer dissatisfaction? What exactly it is impact? And then you identify those. One of the things, remember what we talked about is in the test plan, you identify what are kind of reports you're going to produce it on a regular basis to understand how the progress is happening. Some of those are coming out from the defect tracking system, so around the report from that. Right? You can just do it as, hey, I will give you on an average on a daily, how many test cases we tested, how many new defects we opened, how many defects we closed. All of those things is nothing but a daily defect report. Okay. Second thing you can do it is what is the distribution? Right? Am I seeing it in one part of the systems versus across the systems? Are the defects are wide-ranging, impactful? What are the type of how many critical versus how many like it's kind of cosmetic? How many high priority defects versus low priority defects? I'm opening it. So that's nothing but a defect distribution based on various parameters. Then you can also track it as how many detected versus corrected, right? And that key indicator is important to understand it is, am I going to meet my timeline? So if I constantly see it, more new defects created, then they are closed. I know my gap is going to be wider and wider. It's going to take me a longer time to fix all of that. Okay, so that all of them are nothing but gives you an indication. There are pain points. What do I need to do it? Do I need to start applying it, my risk mitigation strategy that is defined in test plan to start talking about it? Okay. Here is a sample example. I try to like it's minimize the fields so I can fit into a slide, but it's a typical example, right? Is what is the defect status? What it found? What kind of severity? What is priority? When did I identify the wall versus when did I last touched it? And a little bit description, right? So this gives me a view of, hey, where did these things happen? Okay. And then the key aspect is once I identify, right, I need to start understanding what is the impact of that defect is. Right? That's called an impact analysis, right? I need to identify what system areas where the defect came in, how wide ranging it is impacting. Also, another aspect is because of that, how many test cases I need to retest it, how much regression testing I need to reperform whenever this goes, right? Because if there is something in the component that goes and impacts all of the functions, then my amount of the regression testing I have to do it is significantly higher than something which was isolated to this particular component only. Then all I have to worry about is the regression testing around that only, right? So the impact, it's going to be crucial because that's going to identify what it's going to do to my schedule, my ability to commit it and deliver to customer on time, right? So those things are that, and if it's a production, right, I need to also worry about the impact of what is the impact to the reputation, financial impact, and what is it, right? So I don't know, like it's if all of you are up to speed on it, right? OpenAI just released a new chatbot called ChatGPT, right? It's essentially those who have kids need to be careful because they're going to do homework. And then ChatGPT just released a new version, which essentially enables you to tell you whether this thing was generated through some sort of AI or it's human written, right? So, but Google just this week released a computer called Bard to do that. And while doing that, they messed up. And the impact of that mess on their stock was $100 billion in one day. That's an impact analysis. It's not only how much it costs you, but how much market reputation it costs you. Because of that, are you going to start losing the market share because your customer don't have confidence that you can deliver on that anymore? So they're going to go to competitors to get that particular product. Right? So impact analysis it's a crucial tool. Don't think it's only limited to your testing aspect. It could go much more wider depending on when you found it. Okay. Any questions? Anything that we covered it for all of today was setting the testing background. So from last session and today's session, I talked it all. Tomorrow, I'll probably talk altogether 15 to 20 minutes, and that's it. Then it's all you doing the work. So any questions around the understanding the framework? This is the framework. We're going to start executing on the framework starting tomorrow. Online. You had a question?
I have a question about the metrics, defect reports and all.
Mm-hmm.
If I have a test manager, would that be the responsibility of the test manager, or like as a QA we do it?
So as a QA, you definitely have to worry about it because you will be responsible for testing it.
Mm-hmm.
Understand it is how many defects, how they are tracking it, because it also impacts your workload. You also have to keep the test manager informed it as they go through it. They try to pull a holistic picture, but you also need to give your input. Hey, I'm testing this, and it is not progressing as expected. So it's a collective team effort. It's not about their responsibility versus my responsibility. It is the team which is getting impacted, and everybody needs to be hands-on with that. Any other question? All right. If there are no questions, here is a couple of things before we break for the day. One is, I would recommend, as I mentioned earlier today, all of you to be ready in your seat to get started and go at 9 o'clock. Tomorrow, I'm going to start talking about some of the crucial, how you take your requirements and how you start breaking the requirements into manageable pieces mentally to write the test cases. I'm going to start with that. That is going to be crucial. You don't want to miss that. Another recommendation I would do it is, if you are in the town in Columbus, and if you can make it, I would recommend you to be coming here in person. There's a lot of value in terms of interaction. So you're not just going to do everything alone. Starting tomorrow, I'm going to group some of you together to collaborate and work it, because that's how work happens in your real life also. that you do your one view. And then you essentially work with your teammate to collaborate, identify anything missing, to provide a comprehensive view. Right? So it's as crucial as practice. The third practice you're gonna start doing it is some of you, and by the time this course gets over, every one of you come here and talk talk about your view with the team members. That's another skill that you needed when you go into the work. Is you're to present your view with your team and talk them through it. So you need to be confident on whatever you're presenting it, can you talk through it? Okay, so you're gonna be presenting, you're presenting your solution, you're presenting team as you go through it. Right, and it's much more effective to do it in person than over the virtual. Okay, so my recommendation, anybody who is online, if you can make it to be in here tomorrow, do it. If you're not able to make it, you can still do it, but it won't be as effective. That's what boils down to. Okay. Pen and paper, bring it your notebook and pencil tomorrow, or pen, whatever your preferred writing device is. We're gonna go through it. In the following week, that's when you will start needing the laptop.
For the online people who want to be there tomorrow, what do I need to print?
You don't need to print anything. You have all of the documents, right?
Which you go through the requirements.
Go through the requirements document, prep it, ready it, bring your pen and paper. And that's all you will need it tomorrow.
Yeah, if you have to present, you'll be presenting on the Zoom. Basically, yeah, so that we can see it.
Yeah. Or you can just take a picture and we can just walk them through it.
Yeah.
Okay. So we'll figure out a way to do that. Right? If you have a laptop, it won't hurt it, but you're not required to bring the laptop tomorrow. You won't need it.
What exactly are we doing with the requirements tomorrow?
We're going to take it and says, how are you going to start writing the test cases from the requirements document?
Okay. So, and those will be distributed across the people into groups, or like?
There will be, we will have one group online, but we'll also have groups in the class. You will be doing some activity individually and some activities in the group. Again, remember, the goal is for all of you to feel comfortable you can do all the activities, including the interaction with the team members. Okay, so you're going to see a mixture of both individual work as well as the team work. Any other questions? If not, well, we can break it about 30 minutes early today. Remember, I would recommend finish reading the requirements document one more time, because we're going to start diving into the requirements document.
So do we need to read the system design document?
I would recommend both of those.
Entity section, definitely.
Right.
So are we gonna work with the board document tomorrow?
Yes. Right, and having a knowledge of that, it's going to help you as we work through it tomorrow.
So whatever we did the theory, so tomorrow we'll be implementing. all the
Yes.
test cases.
Yes, we are actually going to write the test cases. You need to figure out, remember how I said, you need to figure it out how many test cases you need, what scenarios. We're going to start figuring it out how you're going to come up with
So how do
scenarios.
you make that?
How do you come up with scenarios based on a requirement? How do you break it into test cases? How do you actually write the test cases? You're going to do all of those work tomorrow. All right. Any questions online? Now I'm going to pause the recording. Stop the share.